you could say that about talking about the shadow casted on the moon. He brought up refraction.
Yeah, that's hilarious, dude. Because in order for that to happen, you need an atmosphere from the sun to the moon. And supposedly, the sun and the moon exist outside of the atmosphere, except for the moon, which is supposedly within the Earth's atmosphere, which they just claimed like within the past decade. Literally laughable, dude, how much cope there is in the globe model that when they find something wrong, they just make up a story, retcon the whole idea, and then people just gobble the foes.
Okay, so anyway,
don't forget they bring up refraction, which is also something they're claiming light is doing.
Okay. Anyway, so yeah. Okay, so for the casting shadows on the moon stuff, honestly, because of too many variables to properly, because if you want your in-house tests to be identical to what we observe on the moon, you need to have things modeled perfectly the same with the same light source, same focal point. I mean, so much stuff. I mean, distance for the light. But anyway,
is that a concession?
You raised another point for why gravity or whatever the Earth being a globe is weird, and it's regarding Earth formation. You said gravity wouldn't result in a globe for when the Earth is formed, because I mean, what was that about?
That's for you, Overlord.
Because if, as you live, experience gravity in your everyday life.
One sec, Overlord's on deafening at the moment. He must be taking a call or something, so you're going to have to put a pin in that and remember that and ask him when he's...
But this is something that is a valid question for anyone else who thinks the Earth isn't a globe, because you experience gravity every day. Gravity is where there's an attraction. And how would they...
No, it's not. No, that's not the current theoretical physics definition. It's not an attraction.
Are you joking right now? Newtonian definition for gravity is not attraction. Are you serious?
And go with Newtonian anymore. It's Einsteinian, which just doesn't describe it as being an attractive force.
Wow, yeah, that's different.
You do
space bending, sure, but
you do realize gravity is a theory, and that's all that it is.
Okay, one sec. Overlord's back off deafen. Overlord, Konrad has a question regarding the modelling of
formation of the Earth,
matter forming spheres.
Yeah, you said the Earth wouldn't be formed. You said that gravity wouldn't especially make the Earth as a sphere in its formation.
When did I say that?
That was earlier when you were like, okay, the reasons why the Earth doesn't have to be a globe is because the moon shadow, whatever. And then you said something about, gravity not especially creating a sphere. You did try to talk about something like this. You mentioned something like that.
No, I said I posted a paper from a physics professor for a university who modeled Newtonian gravity on a flat Earth, proving that it's compatible with the Earth being flat and that it's not mutually inclusive to a globe to mutually exclusive of all other shapes. That's what I said, for goodness sakes.
Oh.
I didn't mention, hold on, Fred, before we go on. I just want to point this out. I didn't mention anything about a creation story of things in the past, okay? I didn't mention anything about that, but here's the problem. Gravity is part of the creation mythos of the globe model, okay? And that's why it's so intrinsically linked to the globe, is because people think that gravity forms globes, and therefore because we're on a globe, gravity must have formed it, and they think they prove that by dropping a pen and it hitting the ground. Okay, so that's the ridiculous frailty of your position if you believe in a globe and gravity synergized into a creation event. But I'm just pointing out that the claim of gravity has nothing to do with the shape of the Earth. Okay, that's all I'm saying. Go ahead.
Okay. You made this a bit of an attack by saying, "Oh, look, you believe in gravity. You believe that created a round shape." I mean, it is fair after all, like to extrapolate that it creates a sphere.
No, it isn't.
Yeah, and don't read the room by his voice. Don't bring your feelings into this. It's just sharing information.
I bring my feelings.
You said it sounded like he was being attacking. He's just he has a loud voice. That's all. He's not attacking you.
Oh yeah, I'm not complaining about it, but he is saying like, oh, you've extrapolated gravity to explain a sphere. It is a fair thing to do. You'd have to tell us how you could. How a flat Earth would be formed. How would that make sense?
No, we don't have to. No, dude, no, wrong. You're wrong, sir. You're wrong. Let me explain. It's very simple how wrong you are. So, if I go to a site, for example, a construction site, or any object, and I measure the thing, and it measures flat, okay, it is not my burden to explain how it was constructed. The measurement of the thing itself is independent of knowing how it was constructed or formed. It is wrong to say I must know how it is formed in order for me to understand its shape. That is simply wrong, sir. And so you need to concede that what I just said is 100% correct and you are wrong.
neither of us said anything wrong, to be honest. You were just withholding.
You just did, dude. You just said that I need to have. Here's what you said, dude. You said I need to have an explanation for how it was formed, and I do not. Period.
Yeah, and I'm saying you should because
why should I? No, stop talking for a second. I just want you to explain why should I. Go ahead. Hey, go ahead, dude. Why should I?
Because you complain about how we extrapolate gravity to explain the Earth being a sphere. You say that's like a fallacy when it's wrong. Well, then, I mean.
Okay, friend. Let me break it down for you again. Hold on, friend. Just hold on a second, dude. Okay, I'm going to give you a practical example. I'm holding in my hand an object. Okay, it is a container that holds a drink. Now, on that information alone, could you tell me what shape the container is? Yes or no?
What shape the container is?
Yes, I'm asking you. This is what I'm giving you. This information and this information alone.
Sure.
I'm holding in my hand a container that holds a drink. What shape is the container? Can you tell me from that information?
Like on average, it's oval, like in depth. Like it has a depth, and therefore sort of.
Really? So you never heard of Fiji water, which comes in a square bottle?
Yeah, but it's the same thing. There's depth, and generally, it's like.
Yeah, but it's not oval, dude. It's not oval. It's square. The profile of a Fiji bottle is square, dude. So you notice how you're just making assumptions. Yeah, cool story, dude. So you're wrong.
No,
you're wrong.
I said on average, meaning if you plot it as a graph. For example, you can take 4 points on the graph and you can create an oval shape.
Yeah, cool. Let's say that you're correct. Now, because we both know that the bottle could be square profile or round profile, or even triangular profile for that matter. How would you actually know which profile is the correct profile? What would be the determining factor to determine the container that holds liquid that I'm holding in my hand? How would you know what shape it is?
Okay, by studying the volumetric dispersion, or I don't know the words in English, but répartition, like how the water is dispersed. Yeah, that's how.
Right. So directly measuring the form. Is that what you're trying to say?
Yeah, and then to do
now hold on. Before we go on, I want to give you another caveat. I'm going to give you another piece of information. Okay. So I'm going to give you another piece of information. So it's a container that holds a drink. Now, I'm going to give you the methodology of construction. Okay, the methodology of construction is called metal extrusion. Now, from that, can you tell me what the shape is?
I don't know what metal extrusion.
They take metal. They take a piece of metal and they slam it through a die, which forces it to come out the other side in a particular shape.
Oh yeah, but do I not get more information about the process of how that's done? I don't know.
No, I'm just giving you that and see if you can tell me what the shape is yet.
Oh yeah, based on that, no, but I can look at the volumetric, how the water is dispersed, and then I know.
Correct. So So all of these asides about the creation story of this can are irrelevant to the shape of the can, except for the fact that the can itself is presented, and you can actually measure the can directly. So you keep conceding that the arbiter of the shape of the can is ultimately the shape of the can itself, not some story about its creation.
Well, wait. If the creation was a natural process, then I just have to understand the nature of the factory, I guess. I mean, look, dude, this can go in circles. But check this. I was trying to do something that was sort of...
Yeah, but hold on a second, friend, hold on a second. You know what can't go in circles? Something that's straight. Something that can't go in circles is something that's straight. There you go.
Yeah. Sure, and I wanted to bring that up, actually, because fundamentally, in the end of the day, we can do a real easy test. Easy, you got to put up some money, that's all. Either by driving a car for extremely long distances or preferably flying a plane at the same altitude. And what you do, you fly your plane in a straight line, probably several hundred kilometers, and you turn at a right angle, 90 degrees. And you continue for like several hundred kilometers, and you turn at a right angle again. If the Earth is round, you reach the same point of origin by just doing only...
Cool story. I understand that. Okay, now that's... cool, dude. That's a cool story. Yeah, cool story, dude. So let's just propose that, and let's say that
is what settles it completely.
Okay, cool story. So, going on then, please show us where this has ever been done.
Okay, fuck me.
I know, it's kind of hard when you have hypotheticals that can't validate the reality.
Results. Stop making...
Yeah, good. Hey.
What?
Dude, what I'm trying to point out to you is that all as you're presenting is hypotheticals, conjecture, and philosophical assumptions. Dude, that's what I'm trying to point out to you every time.
Yeah, but doing so, we can figure out what...
Dude, keep it. No, dude. Pay attention now. I'm going to teach you something here. So hopefully you'll listen. I've already told you through direct measurement methodology that the water was measured to be flat. Okay? Why didn't you ask me about that?
I didn't hear that.
I know you didn't because you don't listen.
I don't listen. Wow. Oh, really? This whole time I've been...
Hey, let me ask you this. Hold on. Let's ask a third party. Hey, third party. Did you guys hear me talk about that?
I did. I also heard you explain gravity in a different way than he understood it. I even commented in the chat, I'm hearing two different conversations.
What?
Well, I offer to you, friend, a measurement methodology that has already been accomplished. You're offering me a hypothetical, which you don't even know whether it has been accomplished in three-dimensional free space
I'll
yet.
try to look if it's been done then.
Good luck. Keep looking. I will submit to you that the only thing you're going to find is somebody with a ball in their hands and a black magic marker drawing it on a ball and not actually doing it in reality. There's a lot of conjecture and models and hypotheticals that if the Earth was a ball, then this and that would happen, and then they never actually do it.
Relax.
Dude, hey, brother, I've been in this game for the better part of a decade, going on almost 10 years now, dude. You're not the first person who's made this claim, and you certainly won't be the last that's incapable of presenting the evidence.
Yeah, it takes effort for you. So, I mean, people...
It takes zero effort for me. It takes zero effort for me. You make your claim. I tell you to give me the evidence, and then I wait for 5 years, 7 years, 8 years, 9 years, and I still don't have it.
Because I haven't been preparing for 9 years to try to change your mind, dude. I just came in...
My point is, friend, that 9 years ago, people had the exact same argument. And there's not one shred of evidence for it having been accomplished in reality yet. That's what I'm... trying to get you to understand.
You have to stop being so angry.
Yeah, bro, why are you screaming like that?
What?
I like it.
Hey, friends, listen. What you need to do, guys, is get some testosterone drops, turn your head sideways, and drop them in your eardrums so you can man up.
Bro, it's nothing to do with you screaming. Just be civil.
And a little less soy, too, please.
Yeah, define civil, dude. Define civil.
Bro, I'm just here to listen.
Civil's not a globe.
Bro.
Yeah, hang over.
Nothing but civil. He's been
hang over. Why don't you... Excuse me, I'm sorry. Go ahead, buddy.
I was just going to say, you haven't been disrespectful. You haven't called anyone names. You haven't done any of that sort of stuff. You've just spoken loudly, a little loudly, but like...
Yeah, fair point, though, you're wrong with that.
You really need to fucking out of here.
I have to correct you, T-Dub. I did call someone a dummy in the past 30 minutes.
Oh, shit. Sorry.
Oh, no. Oh, my God. He called someone a dummy, guys. We've got to ban him because of these globe earthers. You know, who's got to be banned. Called someone a dummy. That's it. We're over, dude.
What would you ban?
Sometimes it's not intentionally. Sometimes it's some people who can't talk just only like that way. They talk loudly sometimes because I don't know.
There's plenty of globe earthers when I've been in this room who've shouted loudly because of like their belief, as it's called, or whatever, is getting demolished. You know, they don't like it, so then they start getting aggressive, and then they'll either get server muted or just run away and leave. Or get server muted and run away.
Yeah, but let's not forget, friends, that every person in here has the ability to control the volume which they hear from my voice, right? So I project my voice at a specific volume usually because I'm used to my mic and I'm used to the feedback that I'm getting from my ears. And you know, there's like this autonomous feedback where you automatically raise your voice to the level that's comfortable for your own biofeedback. And then I get consistent complaints that my mic isn't coming through unless I talk in a projected voice. So by all means, go to my icon on my face, turn me down until it's comfortable for your ears, and then quit complaining.
No, I mean, yeah, you have the control over his volume.
Because it's fun. I mean, it's passionate. People are very passionate, and you know they could be loud. You know they could be loud.
It's not loud.
It's not like that they're angry. You know.
I mean, he's not loud to me. I've not had to turn him down at all. But if you feel, Konrad, if you feel he's shouting or something, then
it's not that he's shouting. It's the energy, the tone, the way of.
It's because he's passionate about what he believes in.
That's not passion. That's just slight limit anger.
I'll tell you one thing that he has done. He has cleared the floor in here and allowed you the time for you to be able to support your claims. That's pretty fair. That's fair.
Yeah. So that's what I'm trying to do. But bro, it's my first time I have to deal with like no offense, people like you. So I can't. I don't have a book on this. Right.
If he was angry, if someone was angry with you, they would be over talking you while you speak to try and do stuff. Yeah, and from as long as I've been in here, which isn't that long, you know, even in this entire server, it's like when it comes to globe earthers versus flat earthers, it's normally the globe earthers who are shouting and over talking more than the flat earthers.
Well, look, man, it doesn't matter. Like in the end, people on Discord are just degenerates. So,
well,
you know, the time on Discord.
That's up to you. But we're still waiting for that evidence. But you can't provide any because there isn't any.
No, I can. That's what I'm trying to do.
All right, here, dude. You want me to help you out, Konrad? I can put you on mute, and that way you won't be tempted to engage in conversation, and that way you can focus on getting your evidence. Would you like me to do that for you?
At the same time, why would you mute me? You mute me.
Because you don't seem to be focusing, and you're distracting everyone with talking about people's tone and predispositional emotional states rather than the evidence.
Because he was asking me.
No, dude. You guys started with the... No, let's be clear, dude. The guys in here started making claims about people's emotional dispositions. Okay? That's what went down, bro.
Wait, no.
Oh, yeah, Konrad, you were guilty of that, dude. Don't try to deny it.
No, I was telling you to calm down when you're being...
Oh, you're telling me to calm down? Okay, dude. Why don't you just go get your evidence, bro? Sometime this year.
That's
How about
what
that?
I'm doing right now.
Okay. So just focus on that, dude.
That's what I'm doing.
Hey, guys, just for the floor. Bro still hasn't asked me about the verified measurement of the Earth being flat. Still hasn't asked me about it.
Sure, talk about it then.
Dude, I can't distract you from finding your evidence, bro. That's what we want you to do. We want to give you the opportunity.
No, I have stuff. I just have to look for sources. You can talk about what you want in the meantime.
Yeah, here we go. So via laser transit methodology, measured sample size of 25 miles of water, debunking the globe Earth by 2 orders of magnitude. Because water, according to Pascal's principle and hydrostatic equilibrium, is flat and level on the surface. Water is the gold standard for level throughout human antiquity. If the surface of the water is level and flat, that covers 70% of an object, then that object is flat. If so facto, therefore the Earth is flat. I rest my case.
No, don't arrest your case. I need to know keywords that you're using, that you're, refuting. So you're talking about the keyword over here is water being flat, and what type of water? Are you saying oceans? I need keywords so I can know what we're talking about.
Yeah, dude. So you know the concept of sea level, right?
Okay, so yeah, sea level. What about that? So
right. So when you have sea level on one coast and the other coast, there's not a slope there, because if it was sloped, the water would be pouring over the other body of land, right? Makes sense?
Of course.
Right, so it's level. Water is level. Water is literally the gold standard of level that humans have been using throughout all antiquity and all recorded history, correct?
Yeah. So
water is level, period. Bodies of water are level, period. The end. That's the ipso facto truth.
Wait, so now...
Correct?
There's no problem.
Correct or incorrect?
Yes, but there's no problem over here.
Yeah, fine. So we know that water's level. Okay. So the secondary ancillary claim is that water's flat, which, by the way, is entirely congruent with Pascal's principles and hydrostatic equilibrium.
Yeah.
So now we just have to measure the sucker, right, and validate that level water is actually flat. So you use an efficient methodology like laser transit. You measure a 25-mile sample size. You find out that it's flat, parallel between 2 parallel planes, right? The laser being one of them. And then you extrapolate that out using the hydrostatic equilibrium principles and Pascal's principles over the entire surface water, which it must be, because we all already understand water's level. Therefore, the surface of the Earth's water is between 2 parallel planes. Therefore, the Earth is flat. The end.
Wait, no. Slow down. Now, the way you conduct that test, that's what matters. So, from how the distance between 2 points that you're going to do this.
Yeah, 25 miles. Remember when I said 25 miles 3 times?
But why would you do 25 miles? Why not 250 miles?
Oh my goodness. Let me tell you why, dude. You ever heard of a thing called atmospheric occlusion? You ever heard of that?
Is this basically something that affects the laser itself?
No, it's so the ambient atmosphere at somewhere between 250 to 300 miles horizontally becomes opaque because of the Rayleigh extinction coefficient. So a perfectly clear day, the simple atmosphere would occlude light from passing through it horizontally, okay? So it becomes opaque, like a brick wall. So you cannot do tests that distance. Now here's the problem. You say, why not 300 miles? Because 25 miles is sufficient, dude. 25 miles is sufficient.
It's really not. It actually...
Why not?
Why not?
Why not?
Results. Why not? because of the scale of the Earth. If the Earth is
Wrong.
big, right?
Wrong, dude. Wrong. Hold on. No, I'm not playing these games. No, I don't even care because I already know you're wrong. Let me tell you why. I want the exact. No, I want the numbers. Give me the numbers. Not appeal to big. Big and small are irrelevant. Give me the numbers.
I don't need to give you numbers. I literally don't.
Then you're dumb. You're dumb as a brick, dude. You're wrong, sir. You're wrong, sir, because anybody who does anything in real life understands that tolerances aren't measured in relative claims like big and small. They're measured in actual freaking numbers, dude.
Okay, but...
So here's what you're going to do, dude, before you're allowed to continue to speak in this room. You are going to go and do your homework and find out what the curvature rate is at 25 miles. When you have it posted, you can then be allowed to speak again because you're not intelligent enough for this conversation. And so you're going to have to commit a task to prove, yep, there you go, bro. I don't care. I don't care what math you think you know. If you're going to tell me that you do know math, then it should be even easier for you to come back with these numbers. Now go and find the numbers, go do the math, and come back and let me know the answers. At 25 miles. What is the cumulative curvature drop at 25 miles from an off angle of a level line? Okay, come back with that answer. When you have that answer, you'll be allowed to speak again. Until then, you need to compile your evidence because you're wasting everyone's time that you don't understand these concepts, and we're not going to spend 300 hours educating you with your smuggery about I know math. You're making all these claims that your ass can't catch. It's time to pony up. So bring us the math. Okay, I'll even allow you to cheat and go get the math from a source. All right, so now while he's on mute, practicing some Odyssean self-control from being distracted from getting his evidence, let's talk about something else. Hopefully he'll come back with the evidence. So now he's demanding to be unmuted rather than bring the evidence he was asked for when he was told, when you get that evidence, you will be unmuted. So you already know the terms for being unmuted, dude. So stop asking and just go meet the terms. I want the numbers. That is your token of sincerity to continue in this conversation, is to get the numbers for your dumb claim that 25 miles is an insufficient sample size. So bring us the numbers to back up that claim, or you don't get to speak again. It's that simple.
Now, I know I may be wrong.
Yeah, go ahead, Barrington.
Yeah, boss, I know I may be wrong, but I'm sure I've heard his voice before. Unfortunately, I don't have any numbers to prove that, so please don't mute me.
Yeah, fair enough. However, I'm being so stern with Konrad because he keeps talking these generalities without particulars and without data and without numbers. And so he's making these claims, 25 miles isn't sufficient. You need 300 miles. Then I say, well, what are the numbers? Oh, I don't need to say that. I just need to use relative words like big and small. You know, it's like I go to Burger King and I ask for a large milkshake. And then they tell me, hey, we don't serve larges. We just serve one size. And I go, well, then how do you know your size isn't a large? And they're like, holy crap. And then their brains explode. And this is the level that we're dealing with here.
Yeah, for 17 miles... I drove 17 miles down the highway listening to him deflect and delay and deny just a simple bit of evidence requested. I mean, you didn't ask him for anything out of the ordinary that would happen in any scientific discussion.
Yeah, so for example, my friend, it's very simple to demonstrate. If you go to Wendy's and you order a large milkshake, and you go to McDonald's and you order a large milkshake, and you go to Burger King and you order a large milkshake, it's entirely possible that even though they're all called large, that they have a different amount of ounces content in the cup. Isn't that true? The answer is, of course, that's true. So words like large and small are irrelevant. The guy telling us the Earth is so big and large that this sample size would be insufficient to be able to demonstrate curvature. And then I asked him, well, what are the numbers? And he's like, well, that don't matter. I'm like, well, then how do you know whether it is or isn't sufficient?
I think really what he's trying to say is that the conversation doesn't really matter to him. He's just flapping his jaws.
Well, yeah, it's like this one time I had a client where I was making them a floor, and I made the floor with a giant hump in the middle. And they were walking around their floor, and they're like, this floor feels funny. And I'm like, dude, the floor is so big, bro. So you're full of crap. Give me my money. And he was like, oh, man, I don't really want to pay for this floor. There's something wrong with it. And so I go, okay, bro, let me measure the floor, right? And so I take my measuring device and I put it on the floor, and I find out that it actually is humped in the middle. And then I tell him, dude, if it is humped in the middle, I'm sorry. That'll be an extra $5,000. And then he goes, why, dude? Why do I have to pay more money for a floor that's humped in the middle? And I go, dude, I had to account for the curvature of the earth in this floor, bro. So you owe me an extra $5,000 for my attention to detail. Now, would that fly?
Sounds like good logic to me.
I know.
Only an extra $5,000? Thank you.
Yeah, so then when they tell me, hey, dude, I'm still not comfortable with paying this money, you don't need to account for the curvature of the earth when you're building things. And then I just laugh at them. I'd be like, you're not one of those crazy flat earthers, are you? And then they go, oh, no, I'll pay. Yeah, but the thing is that unless the customer knows the particulars of whether I should or shouldn't be accounting for any earth curve, how could he tell me whether I was right or wrong? I just tell him I have to, and then he just believes me, and then he pays me the money. See how dumb that is? So this Konrad sucker wants to appeal to words like big and small and not qualify anything.
How dare you question him?
So instead of actually getting what he needs to be getting, he's engaging in the text chat. People are literally giving him the answers, and he still can't figure it out. Okay, so they told him that the drop is about 400 feet, right? And so if you think that we don't have equipment that can measure a tolerance less than 400 feet over 25 miles, I don't know, like maybe lasers or something, then you're out of your mind. Military could shoot a laser like with a 4-meter accuracy at like 100 miles or something like that. But this guy wants you to believe that you can't tell the difference between 400 feet at 25 miles because of the words big and small. So big, so small. It's like that's why you got to quantify these things with actual numbers. Konrad, you got your evidence yet or what, dude? I muted you so you'd be able to concentrate, but instead you're yapping it up in the text chat. Why don't you just go to the internet, find the frickin' answer? Or get out your piece of paper, Mr. Math Whiz, and derive the circle segment formula yourself and get the drop. I'm about sick of people that say they know how to do math and they can't even tell me what the difference is from a level line that's not a tangent, parallel to a radial from the center of a circle, and give me the difference of the height from the line where it intersects the circle at 25 miles, the scale. I know math. I can't do that. Well, then just Google it, bro. There's all kinds of earth curve calculators and segment formula calculators you can find, and they'll do the work for you, for goodness sakes. Just come back with the frickin' answer. That's all we want, dude. You can Google that frickin' nonsense. The dudes in the chat arguing with the guys presenting him pre-derived math for a circle of the radius they claim the Earth is and the drop. And they just showed him a graph that was produced with the official numbers from the globe geometry by Globers, and he's literally arguing with them about it. Holy crap, dude.
Crazy, isn't it?
I don't know, dude. The next thing he's going to be on Walter Bislin's site telling Walter Bislin he's an asshole for doing the math so that the flat earthers know what the actual claims are. Like, how dare you, Bislin, put in numbers? We got to use words like big and small so we never have to back up any of our claims.
Hey, why is it that these are the best that the globe side has?
Well, I mean, I wouldn't say he's the best. People like Brenda and Rich Evans, they're the best.
That made me laugh.
They are definitely in a league of their own.
The best Glovers are the Glovers that keep their globe in the realm of faith, trust, and belief. Because then they need to be respected as a religion, just like everyone else respects each other's beliefs and be like, you're free to believe what you want. Those are the best Glovers.
Every day is a struggle to survive. I keep it locked, racing down the highway, looking back on my.
Hey, man, I wanted to hear the end of that. Konrad, you listening? Did you make any progress on getting that evidence yet, or backing up your claim about the side scale with quantified numbers? Happy to unmute you so you can present it. Just let me know. He said, don't unmute me. It's horrible to have someone question. What does that even mean, dude? I'm a threat. He's a threat. He can't even give us the numbers for what the curvature rate is or the drop from a horizontal line at 25 miles, and he thinks he's a threat. Konrad, you're about as much of a threat to the flat Earth as a soup sandwich is to a knight in shining armor. $1,200 feet. Holy crap! 1,200 feet over 25 miles. Where? Okay. You want to back that up? Okay. Where'd you get that from? Did you derive it yourself, or do you have a source? 1,200 feet over 25 miles. I gotta admit, Konrad, I've never heard such a large number at 25 miles, so I'm pretty sure where you got that from is wrong, but I mean, you could correct me if I'm wrong. So you at least have an answer now. Hopefully you have a source to back it or a mathematical methodology that you could present. So since you bore the burden, we'll unmute you so you can present your 1,200 feet at 25 miles. Okay, here we go. As promised, you're unmuted. All right, Konrad, you're unmuted. Your claim is 1,200 feet at 25 miles. How did you come about that number?
Drop is some equation I found online. Like, I didn't like. Oh, yeah, just some equation.
I mean, that's a tiny Earth. I mean, that claim is actually going against Earth so biggie, as you claimed before.
Yeah, I'm not expecting it to be correct, but like, anyway, it's not going to be interesting anyway what I find, but what is interesting is finding sources of people who did real tests to try to test curvature. At the end of the day, is whatever sources of people who've done real world experiments. That's what is interesting.
Yeah, well, what's interesting is that you got a number of 1,200, dude, which is not congruent with the actual globe model. That's what's interesting.
Anyway, do you know the Bedford level experiment? It's a 19th century experiment over 6 miles to test the curvature, which had failed, but then someone else called Russell Wallace in 1870, he did it again, accounting for atmospheric refraction.
No, that's not what he did. That's not what he did at all, dude.
What?
He just increased the altitude of the sticks, dude. That's all he did.
Anyway, there's some other ones.
Right, so what he actually did, friend, is increase the altitude of the sticks.
Mm-hmm.
So you said he accounted for atmospheric refraction. I said he increased the altitude of the sticks.
Mm-hmm. Okay.
Right, so where's the model of atmospheric refraction? Okay. validated that proves your claim that he was accounting for atmospheric refraction? Do you have any of that?
Okay, I would have to. Well, I guess.
Hopefully this time you're more accurate than 1,200 feet at 25 miles. Because let me tell you, dude, that was wrong.
$25 feet of drop in 2,500 miles?
No, he said 1,200 feet at 25 miles.
I'm not, it's not even. I don't even trust it either. So.
Right, dude. You told me. I thought. Well, correct me if I'm wrong, but I thought you said you know math.
Yeah, but I don't know the equation for testing curvature. What I took was random.
What? There's no such thing as an equation for testing curvature. It's just the equation for a curvature of a circle at a particular range with a line that's perpendicular to a radial or a tangent. Okay,
I mean,
you can use it
for the drop. For the drop, I mean, between two distances.
I mean, you had plenty of time to look
why,
up.
Yeah, but why can't you just derive it yourself? You're supposed to be good at math. Just draw a circle and derive it, dude. Use Pythagorean theorem. Use tangents. Use SOHCAHTOA. Use rise over run. Use a circle segment formula and just figure it out, dude.
Yeah, that's if I do the test myself, but I can't do that. I mean,
so you can't do math on a circle. So your claim that you're good at math is actually not qualified in any way, shape, or.
Oh, wait a minute. I was supposed to do it like in my own room. Oh, okay.
No, yeah, dude, it's called a circle. You can literally draw a circle on a piece of paper, attribute numbers to it, then use different formulas and come out with the derivation, dude. What the heck?
No, I didn't think of that. I didn't think like that.
Well, I mean, you're the one who said you were good at math.
I didn't. Wait, relax.
Are you also paying attention to the side chat, because you've actually got flat earthers lending you a helping hand?
Yeah, they literally gave you the answer, for goodness sakes.
Oh.
What, do you want me to do it for you? You want me? Hey, I know. Sorry. I was just about to say, do you want me to do it for you, brother? You need to phone a friend?
Shout out to old dude.
You're basically being fed the answers, dude.
Yeah, cool. I thought I had to rely on sources. That's why. Oh.
Well, yes, that's fair, but I mean, they gave you sources.
No, I didn't think I'd have to actually because I didn't think I have to use a trigonometric circle to make the test of what the drop should ideally be, because in the real world the Earth is not perfectly round. So for that reason, I didn't think that I would try to be using an actual sphere.
Dude, do you know how round the Earth is relative to a circle? Relative to the observer's point? Do you know how it is? The formulas are accurate, dude, out to like 1,000 miles, dude.
Mm-hmm.
Which is, by the way, further than you can actually see.
Yeah.
So you can't see 1,000 miles because of the atmospheric occlusion. It's going to block you at about 300 miles. So the formulas are extremely accurate.
Okay.
In fact, they're accurate to, if I'm not mistaken, like the third decimal place out to 1,000 miles.
Okay, that's cool.
So once again, your claim about how accurate they are is not backed up by the actual quantifications.
Yeah, I was assuming. Not bad. Whatever.
Yeah, it seems to be what you do a lot around here.
Okay.
So for the love of God, dude, could you please get the actual drop at 25 miles?
So I'm only trying to look for real-world examples of people trying to test curvature. That's the only thing that's...
Well, dude, listen, 1 second. If you don't understand what the actual derivation is of the drop at range, then how would you be able to scrutinize whether what they did was correct or not? You just gonna have to trust them, bro. You don't know the actual numbers, so they can just talk out their ass.
Okay.
Do you not understand the problem with that, dude?
Well, if it's peer-reviewed, why wouldn't it be reliable?
If you don't know the actual numbers, you just kind of have to read some sucker telling you that another sucker was correct. How are you going to know whether they're correct or not? You're just going to trust them, bro?
Okay, and if I find something that was already, known to be reliable, then and that you still doubt it, and then I'd have to go further, like you're saying. But first of all, I should at least find something that people find, commonly,
Dude, maybe the first thing you need to know is the actual geometric claims before you start parsing out who is being accurate to those claims or not. You know, for example, the Earth has. Listen, just hold on a second. The Earth has a particular radius, right?
Yeah, sure.
Oh, there you go. So what's that radius?
I don't fucking know. I'm not gonna guess it.
Oh, well, I mean, if you don't even know the radius, then how are you going to be able to tell whether these people are telling you what the curve is, for goodness sake?
Okay, look, relax. I'm trying to look for sources that are good, and then if you don't accept them, then yes, I have to go further, but I'm trying to just at least get sources that are...
Well, dude, yeah, that's fair, but keep in mind, you came in with the confidence in claims, dude. And now we're realizing that you don't. Yeah, you did, dude. You claimed that the scale of 25 miles is insufficient, dude. That's
I assumed it because it doesn't seem. Because I think if you can do 300 miles, for example, then that would be better if you can. That's why. Because it makes sense why it would be better, right?
Yeah, but see, better is a subjective term. Sufficient is all you need, dude. Sufficient is all you need.
So let me ask a question here. So when you go to the doctor and they take a vial of blood to test your blood for some ailment, why don't they, instead of taking a vial, why don't you get them to take like 100 vials or 1,000 vials, so that way they can make sure that they have it right?
Well, that is probably how they started out in the early days. Who knows?
Yeah, they just drained all the blood out of the people coming in to get a blood test, and they kept on dying. And they were like, "Why are all the patients dying?"
That's literally likely how it did start, though.
All right, dude. So we asked you to go find the evidence. You came back with 1,200. That's clearly wrong.
Yeah.
I mean, there's not a lot of. It doesn't seem like there's a glimmer of hope here that you're ever going to find some actual data that's representative of the actual globe claims and whether or not they can be tested or not. So listen, friend, the whole concept of the Robotham 2 Bedford level test was to raise the sticks and get them out of what they claimed was a highly refractive band of atmosphere that was skewing the results. So that means the higher in altitude you go, the more accurate your results will be. The problem is when you go up really high in altitude, you can see things that are orders of magnitude greater than what the alleged curve would occlude. So therefore, by going up higher, you actually disprove the globe even harder. Rest assured, friend, the idea of the Bedford Level 2 that was done by Wallace, I believe, where he had the higher sticks and he was going off of the bridge, where he put a white mark on the bridge. Okay, he was lining up visual information to make geometric claims. Now, when you go even higher and you line up visual information, you find that you can see mountain ranges that are well beyond the alleged curvature of the Earth and the drop rate. Well beyond. So if there's even less refraction the higher you go, then that debunks globe geometry. Even harder. So you're not really having a winning argument here. And then we find out that Mr. Jay Tolan, who, by the way, goes up to in airplanes and uses infrared photography to film the Earth and see things that are way further than they could be seen and that are supposed to be behind miles of curvature, he actually applied a machine learning vision algorithm to it using parallaxial stereography. And he found out that using that methodology, you're looking at thousands upon thousands upon thousands of miles of essentially flat surface, incongruent, again, with the globe claim, because a globe requires curvature. And if it's flat, then it's not curved, therefore it's flat. So again, your claim that increasing in altitude somehow helps the globe's case is actually wrong. It actually hurts the globe's case even worse because it demonstrates that what you're seeing is just laid out in front of you flat for miles and miles and miles and miles and miles. Thousands of miles.
Mm-hmm. Okay, look, I'll actually try to look for some sources or whatever that try to, well, you know, be more helpful, because obviously I didn't expect
have to prove your claims. You didn't expect to have to prove your claims?
I don't want to really claim anything, but
yeah, you probably shouldn't, because it doesn't seem like you're capable of backing any claims, so you probably should stop making them.
I'm not making any claim. Actually, all I wanted to do over here was to ask, like, how do you explain everything else? You know, how does, you know, because it's just that it works well when we assuming the Earth is flat and assuming gravity, things work well together, and like
not everything works well together.
Well,
oil and water don't work well together.
But for example, gravity, it makes sense that it would create a sphere, for example, and not a sandwich or whatever. So,
did you say spherical circle?
It's Indio.
What?
I don't know if it's my hearing, but did you just say spherical circle?
Right, so it would form something like that, right?
There's no such thing as a spherical circle. It's either a sphere or a circle.
Yeah, a spherical object, my bad. Yeah, I said spherical, but yes, spherical.
All right, that's about it.
It makes sense that gravity pulling things evenly, it would make a spherical object, right? So
if gravity pulled things evenly, nothing would ever happen.
If gravity pulls things evenly, nothing would happen.
No.
Yeah, bro, guess what? Before we go on, a university attempted to model this in software, and they couldn't get spheres formed. They had to add additional factors called stickiness factors, and they still couldn't get a sphere to form. So there's no demonstration of gravity forming giant spheres, dude. It's a story. Hold on, before we go on. It's just a story you believe in a religious system that has a creation story that requires gravity. That's all it is, dude. Not demonstrative.
Slow down. It's not a belief. It's a visualization of.
Yeah, but dude, I told you it can't be modeled. It cannot be modeled. Not even in software.
I need a name so that I can look into it. Perhaps.
It's a belief, dude. What you have, dude. We don't even need. Look, I will give you that, no problem. But we don't even need that. Here's why. You have a story about what occurred in the past that you can't validate in the present. That's what it is, dude. That means you believe it, and you can only believe it. Period.
Perfect.
I don't.
Might I just please let me add that claim now is that it's understood that why we're seeing the motion of objects is because of the disproportional distribution of mass. So not even distribution of mass. But yeah, sorry.
What do you mean? Expand on what you're saying, perhaps.
Claim that mass, just its existence, right? It's this property of being able to distort a fabric of the universe known as space-time, right? It's conceptual, right? It's not even like a physical thing that can be, that's malleable, right? So this is just all theoretical. This is like we were talking about before, practical physics versus theoretical physics. But it's due to the uneven distribution of matter in the universe, which is causing that to happen.
Yeah.
Therefore, giving objects a path to take in space-time, curved paths.
Okay. Okay, I think I vaguely see what you're saying. But anyway, do we not agree, for example, that gravity between two objects will pull them together? Are things going to be pulled together? Yes or no?
I mean, you've gone full circle, bro. That's the question I asked you about 2.5 hours ago.
What?
Well, there is a conundrum within that narrative as well that I've noticed. This is just my personal observation, right? That it's claimed that this distortion of space-time occurs because of massive objects. Now, that doesn't necessarily mean that it's huge, right? Because massive in relativity can be tiny, can be big. It's relative to what our size and the thing compared to us, right? Whatever. So if that's what it takes to do that, but massive, and then they also claim in the same breath that massive bodies are forming because of this instance occurring, right? But so where was the massive body in the first instance to cause the formation of the first massive body? It's infinite loop. It's a circular reasoning thing. Like where did it start? Where does it stop?
So your problem is things cannot come into formation without having a massive object. You're saying that's the problem.
Because where was the first one to make that happen in order to form the first thing? It doesn't make any sense.
Okay. Anyway, so I'll try to gather some useful explanations and references that maybe I can present to you guys another time.
Yeah. Why don't you get a time machine and go back into the past to when your claim was occurring and validate that it actually happened, dude? Until then, you got a fancy story that you can't validate.
Well, relax. I mean, I came in here and know, whatever.
Well, I'm teaching you something, dude, that your claims, in order to prove your claims, requires a time machine. A literal time machine, dude. That's the only way you can prove it.
Well, relax. I just said I'll try to have something a bit better organized.
Oh, yeah. Your time machine where you go back and witness these creation events? Good grief, dude.
I'm talking about the Earth as being a globe or whatever. Like simple.
Yeah, that's what we're talking about. We're talking about events that occurred in the past. Gravitational accretion causing giant balls to form. That's your claim that you can't validate. What don't you understand about that?
Oh yeah, of course I can't validate anything really over here because I just came here casually, right?
Yeah, great. Guess what? We can validate in the present that the Earth has no demonstrable surface convexity by measuring water, dude. Therefore, we debunk your creation myth about globes forming from gravitational accretion in the past being the reason why the Earth is not a globe today. Goodness sakes, dude. What don't you get about this? We don't require a time machine for our claims, dude. You do.
Fundamentally, what you guys do is only sort of raise issues or...
Oh, you mean measure the actual Earth? Well, what we do is measure the Earth, find out it's not the ball that you claim was caused in the past by the creation mythos of evolutionary gravity.
So can you actually give me whatever source that you're using which proves there was no curvature seen over certain distances? Because
yeah, dude, we can give you 25-mile laser transit done over water. We can give you a 36-mile one done over land.
Yeah,
we can give you more than that in spades.
Right, so that's what would be the most valuable thing that you could do, is to provide whatever source where it was like nothing noticed over those distances. Yeah, that's what. Because if, for example, think about it, you're here trying to be like, okay, the Earth is not a globe, so the best thing you can do is try to convince other people about that, and the best way you do that is with just giving me the source that should be convincing me, right? Because if I'm clearly right. So if you
finally, dude, you finally got it now. So you finally understand that the crux of the issue is demonstrable surface curvature, and whether it's measured or not, or whether it's measured flat. So that's the crux of the issue. Would you agree?
Yeah, sure. And then it depends on if they've done their test properly or not. But I can't find out if your test that you're referring to is being done correctly or not. So
yeah, dude, our friends here will post for you a documentary discussing the Field Engineer Corps doing 17 laser tests, culminating into the 25-mile test. The history of how they made the laser, how they went out there, what they did, and an associated PDF with all the information.
Oh, there you go. Yeah, that'd be interesting.
And that's just one example. Okay, just one.
Yeah. Okay, that sounds interesting. Like, I'll look at them.
Yeah, the documentary I think is like an hour and 20 minutes, and it's very entertaining. The guy that narrating it is really entertaining. The footage in there, how they made the laser, how they made the aiming sled, all that stuff. It's awesome. And it's the PDF is 120 pages, but most of the pages are infographics, so it's not like a 120-page book. It's like more of a slideshow presentation with a lot of information and data and locations and photos from the sites and trajectories where they fired the lasers.
Mm-hmm. So, what name do I look up to find the same thing that you were looking at?
Well, then we'll post it for you, dude. Just be patient, dude. Okay, it takes time.
Yeah, I did not know what was going on.
All I got to do is go back. All I got to do is go back to 24/7 Flat Earth Discord, where I have a bot that automatically posts the information for me when I prompt it, because it's a relevant piece of information that we have stored over there. So I go here, and then I'm just talking out loud, so you're not going to be bored while you're waiting. So let's see. I go here, bam. Then I type in videos, space, laser long. Then it posts me the link, and then I go links, space, FE core. Then I press enter, and then it posts me the link, and now I have the links, and I'm going to cut and paste them over for you to enjoy.
I really never thought I would end up in a sort of topic like this.
Yeah, dude. You came and you thought that the globe had all this proof, and you found out you have no idea what it's about, and then you were told that through direct measurement the Earth is flat. And so, yeah, that's a shock to the system. I agree.
No, not like this. I mean, it's just no, because like I was planning to watch this podcast with the Argentinian president about economic stuff, because he's a libertarian, kind of an unpopular thing in the West. Anyway, okay, cool.
So I posted it for you there in the chat.
Yeah, I got it.
It's titled "The Greatest Laser Experiment in History." Now, technically, it's not a scientific experiment; it's just a measurement.
But I mean, it's scientific if it's a measurement, right?
Well, dude, I mean, you got to parse out the terms. But scientific experiments are validation of cause and effect. They're not measurements. Measurements are just measurements.
I mean, it's a scientific method to measure things properly.
Dude, there's no such thing as a scientific method of measurement, dude. That don't exist.
I mean, okay, whatever.
Okay, listen, dude, we're just going to parse terms, so who cares? Just recognize that this is not a validation of cause and effect. This is simply a measurement, okay? That's all I want you to understand.
Okay.
Now, this measurement methodology is called laser transit. It's very effective. It's used all the time. It's used in targeting systems for the military. It's used in construction. Okay, it's a very accurate methodology.
Mhm.
But the military even validated even more hardcore with a laser test that they did in the Hawaiian Islands, which was like almost 100 miles long.
Mhm.
They also have the math in here of the WGS-84 projection, right, which is what they were basing their locational reference, because the WGS-84 is a supposed model of a globe Earth with the curvature rates, right? Their initial goal was to test that to see if that actually exists in reality. And what they found at the end is that no, it doesn't exist. The hump of Earth curve that's supposed to be blocking the laser just isn't there.
Okay, so I'll look into this stuff, and just to make sure I understand where you guys stand, you guys basically think the Earth is not a sphere and therefore it's a disk, or what?
No. We think that the Earth doesn't have demonstrable surface convexity, therefore it's flat.
It's a disk floating around in space and is moving upwards.
Oh
my goodness, dude. He's being facetious, dude.
I'm just joking. That. I was being serious.
Wait. So it's not a disk. I'm just like,
no, the disk thing is like a meme that Glowbursters think what we think.
Wait, no, but I'm asking you what you think.
Well, people have. It's a plane. Like flat doesn't have a shape, does it?
It does.
Because if I draw a line, what shape's a line? If you look at like something flat from the side, it's just like a line, isn't it?
Yeah, it is.
That's not a shape.
From the top, it's a circle. So, anyway, I'm asking you guys.
Well, if you look at the Earth on even if you look at a globe Earth on a 2D picture, it looks like a fucking circle.
Yes. So anyway, I'm asking you guys, what is it if not a globe?
Yeah, we don't claim to know the shape of the Earth, right? It's the globe side that's making an exact shape claim, right? They tell us the exact size of it and all of that sort of thing. Like when we're talking about a flat Earth, right, we're talking about the surface not curving, right? So they tell us that 72% of the surface of Earth is water, right? When we go to large bodies of water, if the Earth was a globe, it would have to curve at a certain rate, right? You would have to have a horizon at a certain distance, depending on the height of the observer. So when we go and do these countless amounts of long-distance observations, laser transit, and all sorts of other tests to try to validate curvature, we can see magnitudes further than what you would be able to see on a globe, right? These have been repeated in countless locations by different people in all sorts of different weather conditions, and it's got to a point where we can consistently see way further than what you could possibly see on a globe. And that's taking all of the atmospheric effects into consideration as well. So when we're talking about flat, we're not talking about a disk in space, right? That's propaganda. So if you Google flat Earth, right, or if you go on YouTube, you're going to see a propaganda playlist, and you're going to see a bunch of disks in space and things like that. That's not what any flat Earthers are claiming. Mostly what we're doing is actually testing the globe model to see if it actually matches reality.
Okay. But assuming, okay, so you guys are just stuck at the thing that you're undecisive because it's like, oh, it seems there's no curvature, and you guys, oh well, that's it.
No. Right, there's a lot to it, right? And there's a ton of topics that we could talk about for hours, right, just to get started on them, right? Like gas pressure and all sorts of problems with the globe model, right? But the main thing is you have to have a certain amount of curvature over distance on a globe, right? You have to have a geometric horizon at a set distance depending on the height of the observer. And when we go out, we cannot find it, right? We can't find any curvature. And if you look for the evidence from the globe side, you're not going to get what we're showing you. You're not going to get these comprehensive practical demonstrations that account for the variables, right? Video footage, start to finish of these tests, all sorts of information we can share with you. But what you're going to get from the globe side, you're going to type into Google, right? Who first measured, right, the Earth, right, to be a globe, and it's going to come up with things like Eratosthenes, right? People that just did calculations based on assumptions. You're not going to get people that have actually gone out and practically validated this curvature over distance, this geometric horizon that you must have for a globe, right? So to have everything else that you have in your model of outer space, right, to have space travel, all of that stuff, right, it all relies on the radius value being correct, 3,959 miles.
Right, and so if I understand well, like no other external evidence for the Earth being a sphere will will be useful to you because you'll still be stuck on like, well, the curvature is not consistent. It doesn't make sense.
Holy crap, dude.
Just
Let's be clear here for a second. Yeah, we understand, dude. Okay, listen. There's only one contingent necessary factor of a sphere, dude, and that's direct surface curvature. Everything else is non-contingent.
Okay.
So to say all these other things are going to be trumped by the actual measurement of the surface, well, of course, the surface measurement is the crux of the issue. If the surface ain't curved, then it ain't a sphere.
I was just making sure, and because I'll try to bring something to you guys that is better organized, because otherwise there's no point, right? But for the moment, like all I'm thinking right now is it is hard to probably notice curvature really based on the scale of a planet. So.
Oh my god. Hey, yeah, dude, we got you, dude. Go quantify the numbers, dude, and you'll find that the numbers don't back up your claim. Okay, we have plenty of technology that can tell whether the Earth is flat or not. When applied to the Earth's surface, okay, with direct methodologies, it's flat, dude. Okay, the Earth is flat. Down is down. Up is up. Horizontal is perpendicular to that. Everywhere you go across the whole Earth, water is level and flat. The Earth's flat. There you go.
The thing that what comes to my mind is the trajectory shown for airplanes, which is never a straight line. So it's
irrelevant. Planes are not attached to the surface, dude. Planes are not measurement tools.
No, but the trajectory they take for fuel efficiency.
What trajectory? What do you mean by trajectory? A plane can fly in 3 axes. So what do you mean by trajectory?
From the top view of the Earth's map, right?
Yeah, we got you. Yeah.
They never go when they fly over the Atlantic on the map. They're not going on a straight line, right?
So what? Okay, planes fly. Listen, Fred, I'm going to teach you something about planes. Okay. Commercial planes, okay, that travel consistent routes, they travel in pre-approved corridors. They're decided by flight routes. They're not decided by the shape of the Earth, dude.
Yeah. And
for example, I flew when I was being tasked to invade Iraq with the 3rd Infantry. Okay, I flew from Hunter Army Airfield in Savannah straight up to Maine, into Canada. Then we took a turn and went towards Ireland. Then we went to Germany, and then we went to Kuwait.
Okay.
Why didn't we just fly straight? Why didn't we just fly straight from Savannah straight to Kuwait?
Wait, are you saying?
Keep in mind, a war was about to go down. We're the fighting force, literally the invasion force, the cavalry. Literally, we're going to be the ones doing the attack. We have to get there. So why did we take the long way round instead of just going straight?
What I'm saying, are you asking what you did?
I'll tell you why, dude. I'll tell you why. It's very simple. Because flight paths don't give a crap. That's why. Now, I will tell you this, friend. The entire time we were flying at a fixed altitude, parallel to the surface of the Earth, not traveling in an arc where the plane was constantly rotating. Okay? So, if anything, that proves the Earth is flat.
And also...
Now, your claim... Oh, go ahead, friend. Go ahead.
Also, pilots, I've mentioned this many times because this is relevant because we're talking about planes. Pilots actually use a flat Earth to navigate. They don't use a globe Earth. You know, that's all I have to say. You can carry on, Overlord.
Yeah, so in short, planes don't prove the Earth is a globe, okay? It's that simple.
Pretty much, that's the TLDR of it.
Planes can do whatever they want in the sky, dude. They can go different speeds. They can take different courses.
They can fly straight up as well if it's a jump jet.
Yeah, exactly.
VTOL.
And planes fly, at a pitch relative to horizontal. And we already told you that horizontal is parallel with the plane of the horizon. And we all know that the horizon is the apparent junction between the Earth and sky. And so horizontal is a direct reference to the Earth's surface. And since the water is the epitome of level throughout human history as the gold standard for the term, and the physics of water, according to hydrostatic equilibrium and Pascal's principle, is that it's flat and level on the surface, and when measured, it's corroborated that it is so. Therefore, the Earth is flat. Well, what more do you need to know?
Too much, too fast, dude.
Yeah, dude, it's very simple. Water's flat, bro. What's so hard to comprehend about that? You got any curved water you can show me?
Impossible to have curved water, my friend.
Well, you know what? We got to be fair. You can put water in an ice tray that makes ice cubes that are spherical. So there's some curved water. You could put a droplet of water onto a hydrophobic film, and it'll form into a tiny droplet via, hydrostatic forces.
Yeah.
Right. So yes, you can get a very small sample of allegedly curved water that you could pretend has anything to do with the Earth. But we all know that bodies of water are flat and level on the surface.
Yeah.
Just as we experience.
Okay. Anyway, like I said, I'll try to organize things better. But I was just curious to briefly know what you guys have to say and about. So if you could just make it, more casual and be a bit more chill. So commercial flights, they on a flat map. It's a bit of a parable. The trajectory.
You mean a rum line? You mean a rum line? You mean a rum line?
I don't know what rum line is, but a parable. Do you see what I mean?
Oh, yeah. So if you don't know what a rum line is, then how do you know what the heck you're talking about when it comes to airplanes flying, dude?
Because I'm not an English native.
Yeah, so my point is this, dude. Planes can do whatever they want. They're not limited by traveling directly on the surface. So they can fly in an arc, they can fly straight, they can fly in loop-de-loops, they can do zigzags.
Yeah.
It wouldn't tell you what the shape of the ground is.
You never seen an air show before where airplanes like Red Bull and stuff doing like barrel rolls and stuff? They do whatever they like.
Yeah, dude, that proves. Hey, the Red Bull show proves the Earth is a raptor.
Slow down. I need to better understand the point you're making. You're saying planes can do what they want, but when I'm talking about the trajectory, I'm talking about on a big scale.
Who cares, dude? Doesn't matter.
No, it would be interesting to find out why. I don't have image perms or link perms. I can share a link.
Yeah, dude, there's a supposed, we did this just the other week where some guy said, oh, this distance is too great if the Earth is flat based on an azimuthal equidistant projection. Even based on that, I showed him that the course relative to the speed that the planes can go, plus the fact that there's a jet stream which goes from the tip of South Africa all the way to Australia, right, would cause the plane to travel that distance at a greater speed, right? So, I mean, these claims, dude, can't be validated because airplanes, and when it comes to distances, don't matter.
Okay, let's go even slower than this. So if you look at the link that I sent and you check like the third, or I think 1, 2, 3, the third image, we see that commercial flights going over the Atlantic, they do a very big curve. So there's two explanations for this already. One is actually the winds, the North Atlantic winds are going a certain direction. So that's one thing already. Actually, it adds fuel efficiency. Wait a minute. This is not a completely flat map, I think. That might be problematic.
Dude, do planes have to fly 1-to-1 to the surface? Yes or no? The answer is no. They don't.
Wait. Well, it is interesting to look at commercial flights, the trajectory they take, because they'll take the most efficient trajectory. So it is interesting to look because they're not going to waste fuel, right? They're commercial flights, but people's tickets are very cheap. So it's interesting to look at what companies decide to do.
But we're talking about the surface.
Yes.
The surface of the Earth.
Yes.
Yeah.
Yes.
If you're in a plane, you're not going to see anything.
No. But what the curvature of the Earth might imply for those companies deciding those trajectories is what ends up being more efficient. Like think about it. If the Earth is very, very curved, the trajectory, if you look on a flat map, it will not be a straight line. So if there was no curvature, they would be going in a definitely straight line.
Dude, who cares? Dude, planes don't fly in straight lines, dude. What don't you understand about that?
But they would want to. They would want to, though.
No, you're wrong. You are wrong, sir. Okay, let me tell you, dude. I told you already that we flew on a privately chartered plane. The military chartered it. A Lufthansa big boy took our whole unit to Kuwait. Did we fly straight from Savannah to Kuwait? No. So according to you, we should have flown straight, but we didn't. Why not?
Because of a curvature, maybe?
You're wrong.
Well, then I don't know why.
Most planes, if not all, the only planes that would technically fly, they wouldn't even fly in a straight line, would be the very small planes, that are like hobby planes, little Cessnas and stuff. Because they can't fly that high or that far.
Yeah.
Basically a flying car.
You want to know what's funny, guys? What's really funny is if you actually take the course we took, Savannah, Maine, somewhere, I think Nova Scotia, whatever the heck, Ireland, Germany, Kuwait. Track that course on the azimuthal projection. It's practically a straight freaking line, dude. Wow, interesting. I'm not saying it proves anything. I'm just saying he tried to say, we should travel in a straight line, therefore it proves something about the Earth. Well, my course I took was basically a straight line, dude, on an azimuthal projection. So what does that mean? Does that mean the Earth is an azimuthal projection? Of course not. That would be retarded.
No. I'm just saying it would be interesting, but whatever.
Yeah, it'd be interesting if any of your claims were true. That would be interesting, dude. You said straight line, therefore the model of the path is correct. So that means I satisfied your claim that the Earth is an azimuthal projection. So are you going to concede that I'm correct, or are you going to concede that you're wrong? Which one?
I don't know. I need to visualize the trajectory, but in the example that I
get a map. Get a map, okay, and draw it out, dude.
Draw out from what?
That's all you got to do.
Because I mean, I like you can.
Savannah, Georgia, Hunter Army Airfield, Maine, United States, Ireland, Germany, Kuwait.
Yeah, but I don't know if you did actual stops at those airports or what.
We stopped at every single airport, dude. We stopped at every airport, dude.
Right, so this is not, it's not, because of those stops, it's not a very useful case study because it's only from A to B, which is interesting.
Oh, so now A to B is just A to B. I'm telling you, if you plot out those points, dude, it's pretty much a straight line, dude. So now you're changing your standard all of a sudden. All of a sudden, when your standard proves that the Earth is not a globe, all of a sudden we got to change it. That's not very fair, dude.
You don't understand. You have to, I gave a link of something to visualize, and...
Whatever, dude. You said if you fly in a straight line, that proves something about the Earth. I gave you an example of flying in a straight line,
yeah, but
and then you don't like it.
No. There's no way of actually knowing the trajectory you took from A to B. That's the problem.
Oh, really? See? There you go, dude. There's the problem, dude.
Look,
now you're starting to get it.
Did you even look at the link of those commercial airplanes taking their trajectories?
Yeah, everyone's seen that stuff.
Dude, I've seen it a million times between the difference between a great circle route versus a direct line versus a run line, okay? I've seen those a million times, dude.
You're literally posting stuff a lot of these people have seen many times, so you're not bringing anything new to the table for these guys.
I get that.
Yeah, so you said the path of a plane. Yeah, just hold on. You said the path of a plane proves something about the Earth. I gave you an example of trajectory that is from point to point, and you could track it out as a straight line on a map. So therefore, that proves something. So what does it prove, dude? What does it prove?
Wait.
I tracked a straight line on a map. What does it prove?
It's not helpful because...
I definitely was at Savannah. Our unit definitely deployed from Savannah. You know how we know that? Because our base is literally where? In frickin' Savannah, dude. We went from there to Maine, then we went from there to Ireland, and then we went from there to Germany, and then we went from there to Kuwait. And then we invaded Iraq, dude. Okay, that happened. I was there.
Okay, it's not actually the location from where you go to where you...
Oh, so now the locations don't matter anymore. Wow, dude, your story's falling apart faster than a soup sandwich, brother.
Oh, man.
You're better off just conceding, bro.
No, there's a miss.
No, but if you're changing the goalposts, you're just going to make this argument go on and on and on and on and on. And you're not going to win.
There's nothing to win. I know that.
But what exactly, dude.
Okay.
You can't prove your point with these flight routes because the counterpoint proves a different map projection. So what the heck are you talking about, dude?
Okay,
And listen, friend, if you plot my course on a straight line, that is congruent with a map projection that already exists. Does that mean that map projection is the Earth? Yes or no? I want the answer. Yes or no? Yes or no? If you plot my course as a straight line that I took, it is congruent with a map projection that currently exists. Does that mean that that map projection is necessarily the correct interpretation of what the Earth is? Yes or no?
If you went in a straight line, all it means is you took an inefficient route. That's what it means.
Oh, so how about you answer my freaking question with a yes or a no, dude? Or are you not capable of understanding what yes or no means? Well, know the answer, dude. We're waiting for you to come on board with reality. So, if I chart my course as a straight line and it's congruent with a map projection, does that mean that that map projection is necessarily reality? Yes or no?
I'm
yes
not
or no?
to really visualize what you're...
Yeah, dude, the answer is no, because that would be a reification fallacy. And if you look up reification fallacy, the first entry in majority of dictionaries will say, the map is not the territory. The map is not the territory. One more time, the map is not the territory. To claim it is would be committing a reification fallacy.
Yes.
So we all already understand that this logic problem of just because you can chart a course on a map projection doesn't mean that that map projection is necessarily reality. We all already understand this. You seem to not be able to comprehend this.
I think I understand it. It's only a thing of...
Do you really, though?
Terms.
He's had to explain this to you multiple times, and this is why he's probably getting a little frustrated, because you're not listening.
I am. It's only an issue with understanding the terms, but okay. Anyway, so with what I sent, you guys basically your answer to it is planes do what they want. So there's nothing that explains this trajectory that goes upwards and then back down like this on the map. So you guys don't have an explanation for that, basically.
Hey, dude, yeah, I do have an explanation for that. Planes are on the ground, they gain in altitude, then they're above the ground, and then when they land, they lower in altitude. Now, that is a path that goes up and down.
I agree, but I don't think it affects the result that we see on this map, though, that much. Because the distance is longer than the altitude. So the effect that the altitude change has over that long distance.
Yeah, you know what a plane, hey, cool story. You know what a plane must do if it maintains altitude? Do you know what it must do if it's traveling an arced path? Do you know what it must do? That's contingently necessary and cannot be otherwise. Do you know what that is?
You're going to say
contingently necessary and cannot be otherwise. If a plane is maintaining altitude, traveling parallel to an arc, what must it do? Every moment it's flying, what must it do? Do you know the answer? I'll tell you if you don't know.
Well, then it's an arc. What do you mean?
If a plane is flying in an arc, maintaining altitude in level flight, parallel to an arc, what must it do?
An arc?
No, the plane, not the chart of the course.
It follows the arc.
I understand that, but what must the plane be doing? The plane itself.
Really going straight here.
No. It must be constantly rotating. What? From the plane's own perspective, from the time it takes off to the time it lands, in order to follow an arced path, the plane must be rotating 100% of the time, all the time.
Oh, yeah, rotating downwards, you mean, so pitching downwards.
Yeah, the nose of the plane must be constantly rotating downwards, and the tail of the plane must be constantly coming over the nose as the attitude of the plane is constantly rotating from its own reference frame. You agree?
Yeah, sure, yeah, definitely.
Yeah, cool story. You got any evidence of that occurring in reality?
Okay, fine, I'll look for that then.
Yeah, good luck. We already know. Hey, by the way, friend, we all already know where that's going to lead. In fact, one of our friends will probably post it for you here shortly.
Okay, just give me more work then, I guess. But anyway, so like I wanted to ask earlier, so you guys only have an issue with the curvature of the Earth. You're not trying to claim the shape of the Earth, or you don't have an idea of the shape of the Earth. But if you
I know what the Earth's shape is, dude. I know exactly what the Earth's shape is, dude. I know it 100% for a fact. Yeah, 100%. Not even unequivocally in error in any way, shape, or form. You ready? You sit in your chair because it's going to be painful because this is an epiphany.
No, it's not going to be painful.
Few brains. Yes, no, I'm just telling you, like the epiphany of this. Of the gravitas of this philosophical bomb is going to blow your mind away that if you're not sitting down, you may hurt yourself. So by all means, please sit down.
Just tell me.
Just tell me. Okay, so the shape of the Earth is...
a star.
Earth-shaped.
Donuts?
No, Earth-shaped.
Oh, so you don't have an answer?
Yeah, it's Earth-shapes, dude. Amorphous shapes, dude, that are non-contingent don't have definitive names, dude. Like a tree. What's the shape of a tree?
Cylinder plus other cylinders that go in random directions?
No, that's a composition fallacy, dude. You're giving me shapes of the parts. I want the shape of the whole tree.
But you...
Oh, see, you can't do it, dude. So why don't you just concede that you can't define a tree as a particular shape? The tree is tree shape. Everybody knows what a tree looks like and the shape of a tree, but they can't call it a particular name except tree shape.
It is
right, so you can describe it. Right, so it is, dude.
It's not.
A shape of the part is not a shape of the whole. To attempt to say it's in any way referring to the whole would be a composition fallacy.
You combine them.
No, dude, you don't. You can't combine cylinder and all these other things and then say it's one shape, dude. That doesn't work. What don't you get about this, dude? Why is it so hard for you to just comprehend simple concepts?
No, this is extremely simple. We can do this with 2D objects. For example, a pentagon can be broken down.
Yeah, but that's already a shape. His point is, it's not a shape.
More like
you can take any shape and say, like, oh look, I can take a square, and then I can take a smaller square, and then join them up. You know what that is? It's called a fucking cube. You know, but they're already shapes that exist. What is a tree shape? You don't know. As Overlord said, none of us know. We just call it a tree or tree shape.
We can estimate it. What's wrong with
what would you call a tree then? What shape would you describe it as?
Like if you want to simplify it down, you say a cylinder, I guess.
Well, no, you don't, because you don't simplify. Well, that's like saying, okay, I'm going to simplify a square and just call it a line.
In some cases, you can.
Hey, dude, you know what? Hey, dude, no, we're not even going to entertain your stupidity, dude. Okay, this is stupid, and you should be. No, dude, stop talking. By acquiescence or force, which one? Choose. Okay, listen. A tree that is in the shape of a cylinder is called a pole, not a tree. Do you understand? A telephone pole is not a tree, dude. It was a tree. It was part of a tree, but it no longer is a tree shape. It is now a pole shape. What don't you get about this, dude? I didn't go down the road and I look at all the telephone poles and I say, look at that tree shape. Look at that tree shape. Look at that tree shape. That would be retarded.
Well, only.
No, dude, you're insulting. Room, dude. Hey, a child is not dumb enough to not understand the difference between a pole and a tree, dude. You ask a kid to draw a tree, and they draw a pole. You're gonna be like, why didn't you draw a tree?
Look, it started off with you asking me the shape of a tree.
Yeah, why don't you let us know what it is, dude? You can't. That's the moral of the story. What's so hard to get, dude?
Yes, of course, I can't give you a description that is.
Oh, there we go. Now you're starting to get it, finally.
I never claimed that.
No, you were breaking it down into parts and things like this when you shouldn't be breaking it down into parts. We're looking at the object as a whole. It's a tree. It's tree shaped.
Okay, that's a circular thing to use the name within the definition for describing it.
No, it's not circular. It's what it is. It's tree shaped.
No, that is circular. You don't make a definition by containing the word in it.
I mean, dude, at this point in time, I think you're a troll.
No, you cannot be. You have to be kidding. No, this is.
Well, you've been going around like we've been trying to explain things to you for the past 2.5 hours. I feel sorry for Overlord. His throat must be so dry and almost sore. Having to explain things to you.
Then.
Well, to be fair, I've had my throat replaced with a cyborg mechanism, so I'm good.
All right. Yeah, it's just like we're just trying to get you to understand, but then it's like, yes, Overlord sounds a bit pissy with you because he's had to repeat himself numerous times with different analogies.
No, it was like that since the beginning. So.
Yeah, hey, what shape is the car?
Wait a minute.
The car?
It's like in the beginning, I was the one who asked you the question, what is gravity? That was the original question about 2.5 3 hours ago.
Oh.
You know, I asked you the original question. You never answered it.
All right, so before we go on, dude, because basically you're not giving him a question, you're just making a statement of what he did. Let's open the panel up to somebody else. So what I'm going to do is I'm going to go do some shopping for orange-shaped objects and broccoli-shaped objects and then banana-shaped objects, right?
Broccolis look like a tree.
Oh yeah, exactly. They even call them broccoli trees sometimes.
I've never heard of that.
So let's try to open up the panel for a new person to engage rather than this guy who's just going around in circles. Because I guess he's hoping that if he goes around in circles enough, he can rotate those circles and then get a sphere. And that's not going to happen. So I'm going to unmute a couple people. Hopefully we'll get a new convo going.
I only wanted to.
So we don't have to keep going around in circles, all right?
I only wanted to know the implication of how you.
Konrad, you have had the floor for so long. I
was asking you questions. That's all that I was. I was inquiring.
Yeah, the implications, sir, are that the Earth is flat. That's the implication. That's the claim. Correct. If you want to make claims about the overall structure of the shape of the Earth, which, by the way, could have an infinite permutation, okay, the Earth shape could be infinite permutations of overall shape, dude. That doesn't change the fact that the surface is flat, dude. So I'm going to mute a couple people, and hopefully we'll have a new combo begin. All right, here we go. Let's see if Mr. Sin Cleanser might have something to add that's new, unique, and not what we've been talking about ad infinitum.
Oh, don't do that. Don't do that. We'll get into trouble real quick if you unmute me.
Well, that depends on what you're going to say.
A lot of people in here.
So, Sin Cleanser, do you have anything to bring forth for the globe claim?
Sin's a flat earther, guys.
Oh, Sin Cleanser's a flat earther? I probably knew that.
Yeah, we've all come across it. He's been around for years.
I'll be the Glober today if you need me. I'll be. The flat earth is ruined now.
That's sorry about that. Didn't mean to proclaim you something.
Flat earth is done for now. Watch out.
So then what you're saying is you don't have any positive claims for the globe. Very good. Moving on.
Question?
In a nutshell.
How about Konrad? I know you tried to run. I know you tried to get your point across. I know I missed part of that conversation, but do you have anything new? Because it sounds like what you were trying to proclaim or whatever you were saying has been run into the ground. Do you have anything new to say or any evidence at all for the globe?
Well, no, like I said, I'll try to bring evidence like for tomorrow or something, but otherwise I only have inquiries. And also, just so it's clear, I don't have like an objective or claims or whatever, or the only thing I seek is for things to make sense. So if you guys have stuff that can help make things make sense, then that's cool. And that's what I'm interested in. Otherwise, it's like, you know, it's what makes sense is what prevails. And that's what I seek, for things to make sense. And anyway, what I wanted to ask, I have a specific question. And so you guys are, because this was also an experience to also figure out what your guys' perspective is. And so your perspective is quite simpler than what it generally seems to be, where your perspective is just that there is no curvature. The Earth lacks curvature. Okay, cool. But Overlord doesn't want to extrapolate that to sort of estimate what the general shape of the Earth is. So, and that's not especially wrong to try to do this, because if there's no curvature, then you can estimate what the general shape of the Earth is, right?
Okay. Well, I want to set this straight. For one thing, there's a few positive claims for the globe. We'll get these out of the way first. It'll be really quick. So the positive claims of the globe is that Earth is a sphere, meaning curvature or drop over distance. Number 2, Earth is in motion. And number 3, that there's a gas pressure system existing next to a vacuum without a container. So on the first claim, there's no curvature measured by anybody in history. In other words, drop over distance on the surface. There's never been any motion of Earth detected by any means, any technology, by any person. And gas pressure cannot exist at all without a container. So based on those 3 things, that's what we're going by. Like, there's no curvature, Earth's not in motion, and gas pressure can't exist. So other than that, we don't make a shape claim. As a matter of fact, like was said before, Earth is Earth's shape. Nobody knows what that shape is, because you would have to go to all the extremities or go outside of the system completely and look back at Earth. So nobody's been able to escape reality and then look back and say, this is what reality is. So we don't claim a shape because we don't know all the extremities and all the conditions of the extremities. Do you understand that part?
Yeah, of course.
Okay.
Well, what's this gas chamber thing about? This sounds kind of strange.
Okay, it's not strange at all. You've heard of the second law of thermodynamics?
Entropy can only increase in an isolated system.
Right. So basically, the second law states that high pressure will always go to low pressure, hot will always go to cold, and so forth and so on. So now we know gas pressure. The actual definition of gas pressure is the molecules bouncing rapidly against the walls of a container. That's why we measure pressure in pounds per square inch or kilograms per meter squared, or whatever you want to say. So it's always a surface area. And the reason pressure is measured by surface area, because you have to have a surface area to have constant volume. If you don't have a constant volume, then you don't have constant pressure. So if Earth was an open system, all the gases would fuck off into space, into the vacuum, or into the lower pressure area. And you wouldn't be breathing. You wouldn't be breathing. You're breathing because there's pressurized gas.
Yeah. I get that. Okay. And okay, so now I understand it, and I'll try to tackle that then tomorrow or something. And when you said motion, did you mean you think the Earth doesn't move in space, or you have sort of sources that think it doesn't move?
Well, with the gas pressure thing, we just bludgeoned your space. So there is no such thing as space. Space is only length, width, and height. Yeah, that exists. Length, width, and height, that exists. But what you're thinking about outer space, no one's been to outer space. The Earth is contained and it's stationary. It's not in motion. It's not moving at all.
So you don't think the Earth is rotating even?
The Earth is not in motion. No, the sky above us is in motion. Clearly, when you look up at the sky and you take a time-lapse photography of the stars are clearly moving around in a circular pattern above us. You don't sense any of this motion. And once again, nobody has ever detected it by any means. As a matter of fact, one of the priests of the heliocentric religion, Albert Einstein, said that there's no means to be able to tell to measure if Earth is in motion or not.
Exactly. So, but you're using that as proof that we're not in motion, though.
No, I'm using the fact that no motion has ever been detected. But we clearly have motion in the sky above us, but we don't sense or detect any of that motion here on Earth. Earth is supposed to be moving a rotation of 1,000 miles per hour at the equator, and then about 66,000 miles around in orbit around the sun, and then the sun is orbiting around in the galaxy 500,000 miles an hour, and then the galaxy is supposed to be moving at more than 1,000,000 miles an hour around the Great Attractor. That's 4 different vectors of motion.
Can I say something really quick?
Sure.
Default axioms are not claims. So the claim would be that we are moving because we don't experience motion.
Yeah.
Right. There's a claim that we are in motion without proof, because like what Fletcher just described, because just our natural experience is that we aren't moving. In fact, we use the ground as something in a reference to other things that are in motion. So, yeah.
Exactly. So do you have anything that you could put on the table that you've ever heard of that of Earth being in motion? What would you base that claim on?
Yeah, I'll try to organize something like this, but if you're asking me what I'm thinking right now, well, of course, as the observer, that's not going to be reliable. We have to use external observations, outside of the Earth to prove this, because of course the atmosphere moves with us even as the Earth rotates. So,
well, now you're going back to a presupposition that Earth is in motion, in spite of the fact that there's never been any motion measured on Earth. This has been vetted out by many experiments in the late 19th and 20th century. These things have been done, such as Airy's failure. He proved there was no parallax of the stars. In other words, it's not Earth that is in motion; it's the stars themselves. There's a Morley-Michelson and Morley-Gale experiments with light interferometry, showing there's no motion of Earth. That they claimed what they claimed to find. They were actually trying to prove that Earth was in motion. These experiments, and they were not able to prove what they did find is something is moving, but it wasn't Earth. So what they believed for a long time is that the ether, which is supposedly a medium, invisible medium that everything like outside of us is sitting in, or like the luminaries are in, that is what's moving, and that's what we observe.
Okay, yeah, I'll try to look into that and organize stuff, but just a thought, and be casual, guys, whatever. And this requires to make some assumptions, but it's not like too far out of reach. So the point is, when you assume that the Earth is a globe, and you assume that classical physics is correct, and we just look at how things have been in practice, I don't know, sending stuff out into the space, satellites, everything we've done in practice, things work out well. They've worked out well, and our understanding of classical physics and our Earth has been reliable enough in order to do so much stuff. Like we didn't run into issues in a practical sense, it seems, because if we trust these results that there's no curvature and therefore the Earth really doesn't have any curvature, this would have some practical implications where things like satellites may not work out well, maybe. And things do work out.
Yeah. So since you're speaking of practicality, let's go to practicality. So you're skipping ahead about 20 steps with your satellites, but let's re-ask ourselves this question. So if they're sending satellites and supposed spacecraft and supposedly going to the moon, they had to have the radius or the dimensions of Earth. They had to know that before they did any of that stuff. So I would like you to try to find, or if you know of, how did they measure the curvature of Earth? They would have to have that for all their orbital mechanics, for everything they're doing. And then I have a caveat after that. So do you know of any time in history that anybody has ever verifiably measured the curvature of Earth in order to use it as a reference or a standard of measurement, that they did everything else afterwards with it? Have you ever heard of that?
No, because I never heard of when it was necessary.
Okay, well, I'm telling you, based on your own statements about satellites.
Yeah.
If they're sending these things out into so-called outer space,
Yeah.
none of their trajectories, how much fuel they're using, the speed that they're having to get out into so-called orbit, none of these things would work at all if they didn't have the radius as a measurement that they could use as a reference.
Oh yeah, of course. Okay.
Right. So what I'm about.
So basically, you would want me to demonstrate how they predict the orbit for those satellites.
No, that's too far ahead. No, what I'm telling you is, now here's the thing about this question. If I were asking you this question and they had actually used a measurement, like I said, as a standard, a reference to use for everything else, all their orbital mechanics, if they had actually measured the Earth and knew this information, drop over distance on the surface, which that's what they would have to do, that information would be everywhere. It would be in every school book about the Earth. It would be ubiquitous. You could look it up in a dictionary. How did they measure, or an encyclopedia, how did they measure the Earth? And there would be a Nobel Prize attached to it, no doubt. They've never done it. So here's the other part. Here's the caveat that I mentioned earlier, and I'll finish with this. The caveat is the way that they practically use these things up in the air, like satellites, satelloons. They use a lot of balloons. And we're not denying that they have things up in the air above us. But do you know how they actually locate those things and what method they use to locate their satellites?
Not sure anymore.
Okay. They use elevation angles. Do you know what an elevation angle is?
Go ahead, tell me.
Yeah, an elevation angle is something that they use a horizontal reference frame. The horizon is an analogy, or it's a reference. We use the horizon as a reference to zero to get our elevations from. When they measure elevations, they measure zero as the horizon, and they measure up to their whatever device they're looking at. That's how you get an elevation angle. This cannot be done on a curved surface. Do you understand that?
Okay, so if I understood, it's like the way we're looking. We take the angle. So we take like a person standing. They look up to the satellite, and we take another vector where it's just a straight line from where they're standing, and we take the angle between where they're looking and the vector that is going forwards from them. Right. That's the angle we're looking at.
Right.
Okay.
So that's how they locate these things. That's how they tell where their location is, by elevation angles. Mm-hmm. And do you know how latitudes and longitude lines on Earth were how they came up with that?
Oh.
Elevation angles from Polaris, from the horizon to Polaris, and then all the different distances away. Polaris will drop as you get further away from it. It'll drop in angle. They measured these angles with the horizon as the 0 point. Once again, you cannot have elevation angles from a curved surface. Do you know the rule about triangles? Triangles. What is a triangle?
I'm not going to manage to give you a very good definition, I think so.
Okay, well, it's three straight lines based on 3 points, and there's a rule about triangles. They cannot be more than 180 degrees. Correct?
Yeah. Yeah. Exactly.
Yeah. As part of like Pythagorean theorem. But so they have to start with 0 as the horizon in order to get the elevation angles. That's how they develop latitudes and longitude. Well, mostly latitude actually. So the same thing with navigation, celestial navigation. When we use a sextant and we're out at sea, we set our viewfinder 0 at the horizon. That's how we zero it out at the horizon, and we draw up the protractor part of the sextant up to the celestial body like the sun, the moon, stars, or planets, and we look at what the reading is, and it's an elevation angle.
Yeah.
We use elevation angles to accurately navigate into ports or other harbors. Sometimes these sailors did this without even being able to see the entrance to the harbor because a lot of these islands are covered in fog around the coastlines. Many of them are. Mm-hmm. So we navigate. We practically use Earth as flat, stationary. We measure. We do surveying with planar surveying using a 0 reference, the horizon. So the question is, where are we actually using the globe? Like you said, practically, we're using the flat Earth. in everything they do. Even the people that are supposedly going to outer space are using the horizon as a flat surface.
Okay, understood. Yeah, I just see that it would that there's more stuff for me to try to explain. If like there's just more homework to do. That's what I'm getting. Okay.
Yeah. So I would say the homework, the real homework for someone who believes the globe, and all of us in here went to the same schooling that you did. Like, we all were taught the same thing. It's not like flat earthers were dropped off of a turnip truck and all of a sudden we're flat earthers. We grew up believing the globe too. But what I'm here to tell you is that's all you have as far as the globe Earth goes. All you have is a belief, not fact. All you have is a belief in this globe Earth because somebody else told us this. We were taught this, and all that is an appeal to authority. So it's a fallacy to believe that way.
Nice. So you guys are Cartesian. You doubt everything. I don't think you guys are. It did look like
no, it's not a matter of doubt. It's a reason for doubt. So if something is presented, if a claim's made, or something's presented to you and depicted as being an accurate representation of reality, then, then we're going to take in the stance where we're going to want evidence for that. What's the evidence? Let's analyze what's being presented and claimed as being evidence, right? Does it have any fault? Is there lack of merit, et cetera, et cetera? Does it logically stand? Right? Yeah. Does it match observation, etc.? Right? That's what we're going to do. It's not just this. I'm just going to be this doubtful person, and it's not like that.
Oh no! When I say doubtful, like in a Cartesian way, it's like a scientific thing, like
skeptical, having a critical thinking mind. Oh, okay. Sorry. Yeah, I misunderstood that.
Yeah, because Descartes, he was a philosopher and a mathematician. He did the methodical doubt thing. It's the name of his principle, and it's a sort of method. It's like doubting things like fundamentally and everything. Yeah, it's just a way to proceed.
Right. So here's the thing about that. So we're not just skeptical for no reason. We actually go more along the lines of empiricism, which means that things are observable, measurable, testable, and falsifiable. And repeatable. So if these things are not repeatable, they're not verifiable, you can't test them, observe them, or measure it. Yeah, of course, we're not going to believe that. But we can go out and actually measure the Earth itself on the surface, out in nature, in reality. And we've discovered through our own observations, we see way too far for it to be a globe. So in other words, we found water doesn't curve. Large bodies of water are not curving. We would be able to measure this. It would be like this simple. In 3 miles, you should have 6 feet of drop. 5 miles should be 16 feet of drop. 10 miles should be 66 feet of drop. And 20 miles is like something like 400 feet of drop.
Yeah.
So this is measurable with long distance observation, with longer focal points of zoom cameras and other devices, binoculars. We can see shorelines far off into the distance where they should be below a hump of water. Well, we've never found this hump of water. We actually have an observation called the Black Swan, where we have oil rigs off Santa Barbara coast in California. First oil rig is 6.4 miles, and the other one is 9.4 miles. We see the horizon beyond the last oil rig at further than 10 miles, but we just say, let's say the horizon is 10 miles, and the observer is 1 foot above the water. So at 1 foot above the water, the formula is 1.225 times the square root of the observer's height in feet. That will give you the distance to the geometric horizon of a sphere of 3,959 miles. So we know where this curve edge is supposed to be. And at 1 foot above the water, the curve edge, the edge of this Earth where it drops down beyond your vision, below your vision, should be at 1.22 miles. Well, we have a horizon at 10 miles or more. And that would make the Earth's radius, just by that observation alone at 10 miles, would make the Earth's radius more than 250,000 miles. That's the distance to the supposedly Earth to the moon.
Mm.
So if Earth was that big, it would have a 500,000 mile diameter. So I have to ask you, what is your level of tolerance that you're willing to accept an amount of error in how big the Earth is? Is like it's supposed to be 8,000 miles in diameter, and this observation is showing that if that was a globe, it would be 1,000,000 miles in diameter. So is that okay with you?
Well, there's nothing that is okay or not okay for me because, I mean, I'm not like first in any of this, right? All I the only stance I have is what seems to make the most sense currently. But yeah, so with the problem of curvature, what seems to make the most sense currently to me is the Earth, the scale of the Earth is just bigger than what maybe is understood. That's what would make the most sense.
Okay, so that would make the Earth from the center of the Earth to the outside of the surface of Earth at a 10-mile observation. That would make Earth's radius all the way to the moon.
Yeah, but then everything else is adjusted as well, I guess. I mean,
it would make it out to the moon. So are you telling me? So are you telling me that the Earth is 1 million miles in diameter? That takes the outside surface way past the moon and actually on the way to Mars. So
hold on, friend. Hold on. Before we go on, if you inflate the radius of the Earth, you can't just then scale all the other objects because the celestials are based on angular relationships. So, for example, the sun travels over the tropics, which are the equator, which is a particular circle. So by increasing the radius of the Earth, you're decreasing the circle of which the sun allegedly travels. And so you end up with the cosmos being conical above a giant Earth that is essentially an 8-ball on a pool table. So that completely destroys heliocentric cosmology in total. Absolutely destroyed. So you can't just scale up the celestials relative to the Earth if you increase the radius, because the entire projection is based on the assumed radius. So that does not work.
Exactly.
Now, if you've never seen an 8-ball on a pool table, you'll notice that it's a ball, that it has a little circle with an 8. So that would be the path of the sun on a giant Earth. And so then all of the celestials would be angled off of that. And so you would not have a heliocentric model like you think with a bigger Earth and everything just scaled differently. That's not how it works.
Yep. So everything is based on that radius value. So if that's wrong, like AI was just saying, everything else about the entire system is wrong also. That means all their trajectories, all their, expected orbits, if you want to call them that, all their angles of location to all these different celestial objects or to man-made objects would all be off.
Yep, and all their claims about retro-engineering the relationships of these objects into the past to come up with the Big Bang baloney sandwich. It's all wrong, 100%. Throw it in the garbage can.
Well, according to Jay Tolan, as last video, the Earth is a globe with a radius of 1 million miles.
Just like I said, holy crap.
He did the measurement using parallax, just the way everybody wants you to use parallax. He did it all. It's approximately 1 million miles radius.
So that would be a 2 million mile diameter. Wow.
Yes.
So that means the whole heliocentric model is thrown into the round file, or we call that a garbage can, thrown in the trash. It's useless. It doesn't stand to reason, like you were saying, what makes most sense. Well, your globe, in light of reality, like we just described to you, in light of how much drop over distance there should be, none of it works. That's why we're here. That's why we've been here. Some of us 10 years or more. So now maybe hopefully you understand a little better where we are coming from. I would say where most of us are empiricists. We believe in the empirical methods of observation and testing and testing, measurement, and repeatability, those types of things. We're not just we didn't just wake up, like I said, and I know I might be sounding like a broken record, but we didn't just all of a sudden wake up and go, hey, I think it's a flat Earth. Not at all. A lot of us have spent many years observing Earth ourselves and doing our own long distance observations, and now understand things because of this new information. And that's it.
So basically, why the scale of the Earth can't just simply be bigger is because then the sun is too small. But what if we adjust the supposed scale of the other planets as well and their distances?
No, dude, you're not getting it, dude. It's the orbitals. You can't change the orbitals, dude. They would shrink because they're viewed from locations on the Earth. Okay, you can't increase the size of the Earth and then maintain the same orbital relationship with increased sizes of other things, because the path that they're observed are on fixed locations on the Earth, dude. And if you scale the size of the Earth bigger, the entire model is destroyed in total. 100% destroyed.
Yep. So what happened is the margin of error, like I was trying to explain, the tolerance, they don't have room for any error in the tolerance of the size. So like AI was saying, everything we do and look at is all done from elevation angles, ground positions of these celestial bodies. So in other words, Mars is at a certain location at a certain time of year based on elevation angles from the surface of Earth. It's supposed to be 3,959 mile radius. So everything else is thrown in the trash as well if Earth is larger. And we know it's much larger. We see islands off in the distance. In Hawaii, they see islands over 100 miles away. And I think there's been incidences of lighthouses being observed over 200 miles away. This makes no sense. Can't be so. It's actually impossible for Earth to be a globe. We don't use it as a globe. Nobody does.
Okay. Well, it's late as fuck for me in Europe, so I'm going to take a break.
Yeah. Right. So what we've arrived at is the Earth is clearly flat, as demonstrated by the physics of water, and heliocentrism is obviously false and necessarily so, and so that's the facts.
I mean, honestly, to be fair, the conclusion right now is just that I just have to analyze better what you guys have used as evidence for what you do say. I just have to go through it. That's all. Like, because maybe there's an error somewhere. If there's a mistake somewhere,
there. Oh, there's an error. There's an error with the physics of water that have been the gold standard for flat level for the history of humanity.
Like, I don't know. I can't. All I can say is I just have to look at it.
Well, here's something to think about when you go away, whatever you're doing, like in your moments, silent or your quiet times. Think about how you observe water every time you observe it. So in your sink, it's level. In your bathtub, it's level. In a swimming pool, it's level. In a lake or a pond, it's level. Every place that you know of that you see water, it's level on the top surface, including the oceans. So we know how water behaves, flat and level on top if undisturbed. This is true in all cases. It's another axiom.
Wait, that's easily not true. Videos of astronauts and the ISS where they have a packet of water just floating. It is not flat.
Yeah, green screen. So you're seeing videos that can be falsified, right?
Man.
Dude. Hold on a second. Before we go on, you're talking about water that is under its own intermolecular forces, dude. Okay, that is not the same as a body of water at rest, dude. Okay.
Yeah, the gravity makes
So, for example, dude, if you take a hydrophobic film, and you drop a little droplet of water on it, it's going to make a globule, right?
I get it. Yeah.
Okay, there's no such thing as a globule of a lake, bro. You ever seen a lake globule?
Because of gravity.
Yeah, that's great. So gravity is down, perpendicular to horizontal. The Earth is arranged horizontal, therefore the Earth is flat. Good job. You proved the Earth is flat.
Yeah, at a local level.
No.
And no, dude. Everywhere you go, down is down. Everywhere you go, horizontal is horizontal. There's nowhere you go that's not the case.
Okay.
Level. We use sea level as a level. Sea level is a standard. It's level. That water is level, and it's the same angular level as sea level at every elevation and at every location. So if you do a level water and you're building something, you dig a ditch and you put water in it and you use that as a reference. That's how they used to build.
Yes.
They used to build canals that way. So level is not different at different locations, and it's not different at different elevations. So we use level all the time in everything we do in building. And so every level is the same, so Earth is not curved.
Okay, I'll do my homework, and hopefully I'll be back soon then. Okay, see you.
All right.
Perfect, brother. Make sure you watch that video and read that document about the laser test.
Yep. Pretty much bludgeoned the globe completely.
That guy got the trifecta.
That was good, man. I thought I could tell from when I first came on, it sounded like he needed a little special treatment. so we finished it off for him.
Sonny, bro. So let me congratulate you on how sharp and concise, precise, and developmental your conversation was. Very well done. I appreciate you in this mindset. I like to hear it. Good for you, brother.
Hey, thank you very much, man. That means a lot coming from you. I've always looked up to you and your conversational skills and the knowledge of this topic. And I've learned quite a bit from you and other people like you all throughout this whole journey. So it's a process, and I'm grateful. Thank you. I appreciate that.
Also, congratulations to the panel for not having an interruptive chaos. That was actually not, even though it got hectic a few times, it was actually very listenable.
Yeah, and I want to thank Flatsy and T-Dub, both of you. I appreciate when you guys stepped in. Was very appropriate. It was at a good timing. That was impeccable. I love that.
Always happy to help keep it on topic and hopefully synergize with whoever's talking.
Well, see, that's where our strength really lies, not in the individual, but in us collectively, because we're unbeatable with this mindset. Like when we're focused and we're able to have a relaxed conversation, nobody's getting tripped out, and we just present the information. So with all of us working together as a team, we do so much better. So yeah, I like that. It's very, very rewarding, actually.
Yep. Yes, and to counteract, if in case anyone's getting too nicey cringe vibes, let's just counteract that a little bit with some spice. Yes, iPhone users, you suck. All right, I rest my case.
I had to leave for a second because I got a call, and I was like, I'll just exit out of this call and take my call and then come back. So that's what I did.
Yeah, that's called synchronicity. So I like that. We're not all crazy on the same day, so thank God for that.
Hey, you speak for yourself.
Who are you referring to, though? Then I would have to know the reference you're using, like, are people around you kind of crazy? I don't know. It could be.
Have you ever met that Demont guy?
Yeah. You know what? In spite of whatever anyone else might say, I kind of like the dude.
I do too sometimes.
I don't mind the rough edges at all. Like, I appreciate the personalities in here. It doesn't matter. We all get to hone our skills, and I think we're all doing just great. Even Denmark. Just joking. I like it when Crit was saying to the one guy a couple of weeks ago, he's like, well, see, you've painted yourself into a corner to where you only get to speak to Denmark now. He's the only person that you can speak to now because of how you painted yourself into this corner. There's nowhere else to go but you in Denmark. That was so funny, man. That was precious. That would be like great to save.
Yeah, sometimes we get people in the messages. Sometimes we get people in the message be like, why is that guy so crazy just going off on the Glober and none of the mods are doing anything? And then I chime in, dude, it's because we want that guy to be punished.
Yeah. I mean, there's no victim. There's no victims here. There's only volunteers.
Exactly.
Yeah. That's
like nobody forced anyone to stay and be democized. It's like you're a willing participant, dude. The door's right there. You're not chained down.
Yeah, and usually it's like Denmark goes off on people usually after they've been bludgeoned around their globe all over the head area, and they still don't get it. Like, we give them open book test. Here's the answer to this question. What is the radius of Earth? After we told them, yeah, it's 3,959. Now, what is the radius of Earth? Like, I don't know. They still don't know. Like, how much drop over distance in 5 miles? It's 16 feet. Okay, how much drop over distance in 5 miles? I don't know. So then it's time for Denmark. Take over.
Well, usually they'll be being rude to you guys too, or just being dickheads downright anyway. You know what I mean? So they'll come in and say something to them.
Well, yeah, because they double down. Like, they get caught in being intellectually dishonest, and a lot of us get tired of that after a while, and we kind of back off. But they want to keep going, and they keep enlisting themselves in a fallacious conversation. So, yeah, they need some more bludgeoning, and some people need a bigger stick to get hit on the head with.
Yeah, because sometimes a clothespin ain't enough.
Yeah. That's why we don't see a lot of the Gem Pandaites in here there very much anymore, because, well, most of them all have been banned multiple times and given chances and then banned again, right, AI?
Yeah, they usually don't last too long with their behavior.
No.
I think it's weird if I just say hello. I'll come in and be like, hey, you guys, something. They'll be like, oh, shit, party's over, Democ's here. If the Glovers say that, they like totally give up as soon as they hear my voice.
Well, you got a really Democky voice, if that means anything to you.
Well,
yeah.
your reputation precedes you.
Exactly. Democ is a verb, not a name.
Right?
Yes, they don't like to be democracy.
This is a democracy.
Democracy. I love it. Awesome stuff.
It'll be weird to the ones that are actually truthful or sincere. You know, when we talk, no matter what they say, you can say the craziest things you want to me, and I won't say anything about it if you're a cool, sincere person about what you're saying.
Yeah, exactly.
Yes, that's pretty much it with me. And if they act convoluted or say one thing and then 2 seconds later say something different, like, hold on, you just said, no, I just don't let that shit ride. I'm very elucid, as I would say, or lucid when people say weird that shit and double speak, and I hear it. I don't like it.
Yeah, exactly. Yeah, we become really sensitive about that. You know, we can spot it out. That's what I don't think they understand about us. That through this process of these conversations, through all these years, and a lot of times every day being on here, we've heard it all. So when we hear something that just doesn't sit right, now, like you were just saying, some of them are honestly curious, and there's a lot of ignorance out there. And I'm not saying that to cut anybody down. A lot of these people, they just don't know. They haven't been exposed to the information. So that's fine. I mean, when they're curious because of that, that's one thing. But when they've been around here for 5-6 years and they keep coming back with the same ridiculous arguments, then yeah, they need to be kind of like dealt with appropriately. So we know how to do that. But yeah, they miss the intuitive part that we have here, that intuitively we can pick up on that honesty pretty quickly. And I used to get really hyper about it. Like, people know me from years back, man. I would get quite upset and show my frustration and vent it out on them. And I think, you know, I've learned throughout the years, you know, like I can be calm and just present the information, and that's good enough. Like, they want to keep on being dishonest and lying to themselves about this information. That's up to them. Like, go ahead and do that. But we're going to call you at every step of the way if you're wrong.
Yeah, this arena has helped me in my personal life just deal with a lot of things. I'm grateful for it.
Yeah, I also like the Socratic method, the isocratic method. I'm pretty sure when you just get down to the brass tacks and be like, okay, we're sitting here together. What do we do? That's it, right? Isn't that?
Yeah, really. I mean, somebody's got something, a point or a point of conversation. They want to bring it up. So I think what you were saying about your personal life, because you can kind of like listen to somebody and see like what they're trying to say and what their motives are. I mean, you can kind of like read between the lines, and if I don't know what their motives are, or if I'm not sure of what they're trying to say or what point they're trying to make, I can give it a moment, let them speak up before I make a decision. Then I can ask appropriate questions. But also like that intuitive part. I don't know if that's what you're referring to, but the intuitive part, like you kind of learn like the way people present themselves, like if they're being dishonest or not.
Well, yeah. And the
speaking of that, hold on, friends. Hold on. Before we go on, please vote for me for Liar, Fraud, and Nefarious Shill of the Year. I'm hoping to beat out Witsit and Jaren for the prize money because I could use it for more super chats.
Oh, crap.
I don't know. Jaren's pretty up there, man. You got some tough competition this year.
That was
Will Duffy said it's okay to lie and deceive people. So
did you see the new video about Eric Dubay?
Oh man, yeah, he has a tough running AI this year, but I'll vote for you.
Yeah, that was a cheap plug. I think you're going to lose that AI.
Dude, I think third place is $500 in merch store credit. I guess I could buy the merch and pawn it to get super chat money. So I'll accept third place.
Super chat.
I think they should change it around so that the biggest loser, is the biggest winner in this particular competition.
Yeah, flip it around. You thought you were the biggest loser? You're the biggest winner.
Because you lost at the Liar, Cheat, and Thief contest. You're actually the first prize winner.
Super chats. I think they should have my voice yell out that whenever somebody's going to do the super chat.
You got to join some of the ball busters. Start saying it. It'll catch on eventually.
I'll pay money. I'm gonna slander you with a super chat. I'll cut you out. I'll spin my loot. You'll feel bad.
Are you trying to usurp Booger? D-Monk?
Super chat.
Killing the job for a minor. Gosh dang, D-Monk.
Whatever.
Super chat from a Glober. That's all we want. Yeah, have the Glober give super chat. Yeah, they do, so they can slander them. That's great.
Dude, I've won entire debates in super chats. Like literally, go watch the debate where it's Nathan Thompson and some other guy versus some other dudes, and the debate topic is on MD. The debate topic is, does the Bible teach that you're supposed to be vegan or something like that? And I just super chatted some verses and then just took my victory and left. And then Nathan Thompson tried to answer it, but he messed up. And then I said, wow, this was the best $50 I ever spent winning a debate in the super chats. I'm going to go buy a steak and eat it now. It's like, dude, how do you show up to a debate?
It was rare, but you roboted out.
When your debate's gonna lack, super chat.
I'm just waiting for them to go over the Brian and McBooger Eater debate. That was gold. Or we'll get to it in the next 6 months to a year. We'll see.
So it's just absolutely great that, all that money spent on all that travel and all those whatever logistics they had to do to go down there and do this final non-experiment, that doesn't change a damn thing. Didn't change anything. The Earth is still flat, measurably so, and what the sun's doing, nobody freaking cares. Who cares?
Yeah, but now you got Dubé up there saying it's all fake. Oh.
I know, that was like over the top though. He's saying they've got green screens that go completely 360 degrees around. Like, I don't know if they would go that far. I mean he might have. I think he's got a point. It's got a point, but I don't know if that's really actually what's happening. But if it was happening, it wouldn't surprise me. The Globers would do something like that.
Well, they'd try anything, wouldn't they?
Yeah, pretty much.
Yeah, it's like we're fine here because we can see through all the BS, right? We know it doesn't do anything. But man,
it's not hard. It's not hard to set up a 360 green screen with a camera, is it? I mean, come on. It's ridiculously cheap as well.
Well, I don't know. You'd have to go through every single freaking thing to disprove it. You can't just make a blanket statement and over a minute and say it was a green screen. Especially Eric Dubé, the #1 mainstream flat earther, and then you go to the comments and you see all the other flat earthers agreeing with them and saying, "Oh, they faked it, oh blah blah blah." It's like, it pisses me off, man. Like I said, it was the final confusion or the final whatever the word you want to call it. Social experiment. There we go.
So I take it you're not a fan of Eric Dubé then?
I don't mind him. I don't know, I need more cowbell. Like a 7-minute video to say it's fake. Like, come on, bro.
Yeah.
Yeah, I like Eric Dubé, but I think that video isn't very good. And I think the arguments are really weak that it was faked. Lit above where they are. close to it.
But do you find those pictures of the sun appearing to be in front of the clouds? Do you find them compelling? Do you go, oh, it really does look like that, or that's a funny and rare effect that I don't like?
It's a rare effect, but it goes to show that like the sun that we're actually seeing it's very like apparent, right? It can, like, you're not looking at the source by any means or anything close to it. I mean, you're seeing an apparent sun. I mean, that's just evidence towards the sun that we see being apparent. That's all. Like, there's some pretty extreme examples.
I mean, eggshells, should we be seeing that? If the sun's 93 million miles away, how do you justify seeing the sun looking so local with corpuscular rays?
Because that's how parallel things look, right? If you put your head between train tracks, you'll have these lines that are parallel, looking like they're running into one another, right? If you get your eyeballs right down equidistant between the train tracks, you have two lines that are definitionally must be parallel to one another in order for the train to work. But they'll look like they are two lines heading in opposite directions, crashing in the middle. Something can be parallel. I mean, you can do it with a drainage board. Like, just get your phone, go up to the drainage board next to the sink in your kitchen, if you've got those lines in the metal, and just put your phone up against the surface, and those lines will all appear to converge really sharply towards the lens of the phone. It's just how perspective works. I don't need any bending of light or any refraction or anything. It's just that parallel things look like they're converging depending on the angle to the...
Yeah, I agree, but that's in the distance at the limitation of your view. When we're seeing the sun rays come from a source that seems to be embedded in the clouds, I don't see how you could use that argument in that instance.
Well, if I agree with the first bit, I mean, that's smuggling in the assumption I agree with it embedded in the clouds. I don't think I think there's only the very rarest of photos that seem to suggest that, but I've looked at the sun many, many times throughout my however many tens of thousands of days on Earth, and I've never, ever, ever had, oh, geez, that looks like it's in front of the clouds. Every time I've looked up at it, maybe because I've got the baked-in assumption that it's millions and millions of miles away, but I see it go behind things all the time. I've never, ever seen anything go behind it. So it's the furthest thing that I can discern. I don't think that it ever looks like it's in front of the cloud. It's never struck me that way personally. I think there are photos online, but I can't vouch for them being that compelling in reality.
Yeah, I'll post a few. But yeah, I agree that we do need to take perspective into consideration. I think it is part of it, right? Obviously, perspective doesn't all of a sudden not happen when it comes to sun rays, but some of the examples are so extreme where you see the light rays, scattering off the clouds and branching out, like diverging in ways that don't fit with how perspective would work. Right? They're going like way off to the right or way off to the left. Like, it's not explained by perspective, but perspective is still at play.
What I'm describing with perspective is, take two train tracks, but now there's no Earth. They're not on the Earth. So train tracks in a kind of Mario Kart, they're just disappearing through an empty void. But sparkle some coloured lights through it if you want, just so you can see which way's up. Those tracks, if I can move my perspective, I can make those train tracks appear everything from perfectly parallel pointing left to perfectly parallel pointing right, and virtually everything in between. If I can go either side of them, so I can look straight down, keeping them across the lens, or straight up, keeping them across the lens, and that will give me two completely opposite perspectives. And then I can go from there at any rotation, including between the train tracks, which will now have them pointing perfectly inwards. What I'm saying is I think I can get every angle possible out of two parallel straight lines. I don't think that, so that second one you posted, it is good, but it's I think that's a function of how that's taken the photo. I've seen the sun set. And India's very smoggy, and I lived there for 5 years. The sun goes red, so you can really stare at it as it sets. You find that everybody who sits along the beach in Goa stares directly at the sun because it's like this gentle red, doesn't hurt your eyes at all. And I just never had the impression that it looked at all like it was in front of the clouds. I agree that photo makes it look like it is, but that photo also doesn't. That looks like a camera trying to capture it. That's not how the sun and the clouds present to me, because my eyes can adjust better than that. I think that's a funny camera effect.
Have you seen some?
Have you seen that personally?
I never would have really noticed. I mean, I've definitely seen it within the clouds, but it's hard to gauge whether it would be. It doesn't quite look like in these images what I've seen from memory.
And my feeling is that cloud's obviously in front of it, right? So that bottom one, that cloud going in front of it, maybe I can draw it for you, but see the bottom one, see how the cloud's going past this gentle horizontal angle. Now imagine the cloud is there in front of the sun, but it's a thin, gentle, hazy cloud that passes in front of the sun. What would it look like? And I think what it would look like, perfect. The last one you posted is great.
Wouldn't see it.
You wouldn't see it. It would just be a light bit, but it's lit up by the brightest thing known to humanity.
I think it would that's exactly what it looked like. It does look kind of like it's in front of it because we can't see that line in front. But the line in front, the only way we could see it is if it were darker. And that's what we get in the bottom of the frame. But if it's a gentle, light, misty cloud, it will be as much blotting out the sun as hitting particles within that and brightening. And there would be a range in which that happens where it would be pretty much even.
There's an infrared
it's brightening
one,
up as much as it's darkening it, and it would look.
Someone actually did one with a filter on it, and you can actually see the clouds behind it.
Behind it? How you can't see it behind it? Like you can only go.
It's got a filter on it, and it cuts it down, and they run it in negative, and you can see it, and it's like, oh wow, it looks awesome. I'm trying to find it.
Well, you can show the clouds behind the sun.
No, you can see the depth of it, the light shining on the clouds that are directly just to the left and to the right of it to see depth perception. So you can see that there are clouds behind it.
Clouds behind? You really think there are clouds behind the sun? Honestly?
Well, that's what this bloody video shows when they flick it over to negative.
I'm sure you can alter an image to make it appear that way. I think I could probably do the same thing. But I'm saying, do you really think in reality that's what it is? That it's clouds behind the sun? Like, how could a cloud... The sun's hot, right? Would you agree with that?
It's not the sun that you're seeing. It's It's just apparent.
Right, but then something can't be behind it.
It's just appearing.
Saying the clouds.
We'll have a look at what Roots just posted. You can see look, it's just lighting up that tiny little section. You can see the cloud behind it. I mean, it's pretty trippy. I mean,
that one does. The Roots one's good. That is really good. Yeah, it looks very local. Cool. It's good fun. That is good.
Yeah, it's just appearing. No one thinks that's the actual sun. He's like hovering right there. I mean, I'm sure maybe there's some flat earthers that would try to argue that.
Well, that's the only reason I suddenly squawked, because it sounded like... Is it Matrix talking? Who was saying that? Tito?
Matrix you were talking to.
Well,
yeah, I just don't see him. Oh, Banhammer, he's going by Banhammer now. I was like, oh, sure, it was Matrix. It sounded like he was saying the clouds are behind it. Like, in reality, the clouds are behind the sun. And that's what I was trying to understand when you were saying that, Matrix. Is it like you think that the clouds are physically located behind the sun, or it just appears that way or something?
There's a whole heap of videos, and you see the clouds wafting across in front of the sun, and then they flick the image over to negative, and you can actually see the sun go through the clouds. So you can see cloud behind as it passes and in front. So
how would you know that it's behind, though? That's my question.
Okay. If I shine a torch on you while you're standing, you are a bright light, you're standing in front of a wall. The light from you projects onto the wall, correct? Now, I'm not standing at the wall. So? I'm not standing at you. I'm standing on the opposite side. I look at you. I can see your light projected onto the wall. That's how I know there's depth. That's how I know you are in front of the wall.
Right.
And that's what
I guess my question would be, sure. So I guess my question, if I use your example...
That's why I'm trying to find it. So you can look yourself and go, that's bullshit, or that's awesome, or whatever. I don't care.
Yeah. I guess the way I put it, if I did the same thing, is like, if I'm standing in front of the wall, you go, well, I can see that the wall's behind him. But then, if you'll excuse the ludicrousness of this, I go up to the wall and with a perfect jigsaw, cut through the wall and cut out a portion that is perfectly matches me standing in front of it. You could say the wall goes behind him, but be wrong, correct? You can't tell what's behind something else.
The issue with this, it's not a still. It's actually video. It's moving.
Yeah.
And you can tell it's moving. That's the problem.
Yeah, I just think funny stuff can happen in videos. You wouldn't be surprised that you can get something that makes it look like the sun is in the clouds. I'm just trying to understand if you feel that, that in reality there are clouds behind the sun.
When they show it straight up, you can't tell. It just looks like bright fucking light, like all the ones that you've just seen there. Bright light, can't tell. It just blurs everything out because it's so bright. But when they flick it to negative, all of a sudden it stands out like dog's balls. It's like, holy shit.
Yeah. I still haven't heard a good explanation for what DJ's posted there. Like that, when I first saw that, I went, "What? That's killer, man!" Like, how the fuck does that make sense if that sun is 93 million miles away in the distance?
Which bit? Which one are you talking about now?
The hotspot.
Oh, hotspots should happen. It's good. Like, you can't both have. This is something admittedly, I'm going to admit before I say this. Nobody here just said this, but I regularly hear flat earthers say, "Where is the specular highlight?" Right, and they show you a picture of Earth, typically at a fucking desert, and go, "There should be a shiny spot on this ball." Right, because balls have shiny spots and they show you pool balls and stuff. You can't both have, which I appreciate nobody here has said, you can't both have, why don't we have specular highlight, and then show an image of it bouncing off what could be clouds but is probably ocean, and say, therefore, also, when there is specular highlight, we're still going to say that's sus. Well, there should be shiny bits. What do you mean? Because every time the shiny spot in the sun is directly between you and the sun, right? You can walk along a beach line for 24 kilometers, and every kilometer, the sun will be pointing magically always just at you. That's how the sun. The sun will also be. because that's the direct line between the bit of ocean that you can see where it's going to bounce at that level, and it's directly in line horizontally, that's perfectly in line with the sun. You get the shine where it is, and you don't get it where it's not, particularly when it's covered, when bits around it are covered with cloud.
Man. There's no reason why it could be closer to the camera, further away from it, not even there at all.
Because there's clouds in the shot. Look, there's clouds. I think you're just seeing a bit of ocean there. That's what it looks like to me. I may well be wrong.
That's the
As I said at the beginning,
clouds.
It could be on the clouds, but the clouds also, I expect, if you get a long flat bank of cloud, you will get a lot of white peaks of that cloud all stacking up in the perfect orientation to bounce it back at you. It's just not that interesting that there would be a shiny spot on a thing that's fluffy and white and covered with a lot of water. That doesn't surprise me, is all I'm saying. That's what the sun, even if it's 93 million miles away, it should sometimes bounce off things, and it will only ever bounce off them in a direct line between it and my eye at the angle that it happens to do so at. If the
That's not a direct line, man.
Which is it, too far left or right in that frame?
Why isn't it off to the fucking right?
Because that's
the left.
That's exactly how reflection don't work. Because that's the angle that it does bounce at. It bounces at the angle it bounces at, and not other angles.
How do you know?
How's that confusing?
How do you know it has to be at that angle? Like, why does it look like it's directly
angle is it
below
at? You tell me. You're the one who knows it's at the wrong angle. What angle is it coming in at?
I'm not saying that. You're saying it's at the
I'm
right
saying
angle.
a thing that's shiny should sometimes bounce light into your eyes. That's where the shine's at, wherever it's shiny. You're being like, why is the shiny bit there?
With the spot
I don't know,
directly
because it's where the shiny bit's at.
Eggs,
It just doesn't surprise me it's
listen,
shiny, you know?
Eggs, listen, why is the shiny bit directly underneath the fucking light? Why isn't it halfway between us and the light source as reflections do?
It might be halfway between you and the light source. You don't know the distance to the shiny patch nor to the sun. And it shouldn't be halfway between. It should be equal to angle of incidence equals angle to reflection. So what that's going to be...
So why is it underneath it then?
It's not. That's just all you can see. Come on, man. You've got to be able to get...
It fucking looks like it's underneath it. Open your eyes.
Right. But how much of the Earth are you seeing there? How far are you seeing there? You're trying to test the globe, so you've got to accept all of the globe maths right now and show that it's wrong. And in order to show that it's wrong, you must accept that it's true in order to disprove it, right? So how far are you seeing then? 100 kilometers?
I've got to accept something's true before I disprove it. What kind of fucked up logic is that?
Well,
I
otherwise
don't have to accept any of your shit. I walk outside, I don't see curvature, and now you're telling me I've got to accept curvature so I can disprove it.
In order to show that something is false, you must take its claims and go through them, presuming, like, operating as if they're true and showing how the predictions fail, right? So you've got to say a globe of 3950
You haven't
must
made
have
a
a
prediction
horizon.
yet.
I have. I've made a prediction that a shiny thing will shine stuff into your eyes, and that horizontal, where it is left and right, will always be directly onto the source. And how far it is from me to it is going to be probably roughly angle of incidence equals angle of reflection, right? So with that, I go, how far away should it be? I don't know the height of this thing, but if I were to guess, that's 400 miles. You're seeing 400 miles. And then, because we're taking the globe claims and testing, we're going, it should be curving away from me at an even rate. Somewhere on that curve, somewhere between under my feet and where it terminates, a shine will probably exist, because that covers almost every tangential plane. And the thing that is most perfectly on the tangential plane, that pointing at that light with angle of incidence equals angle of reflection, that's the bit it should be hottest. And then it should be a line radiating from that point into my eye, going all the way along the water tops, if there's a bit of chop, right? And we've all seen this at the beach. That's what it should be. And you're going, but why does it look exactly like it should? Because I don't get the angle it is from me, what distance is from me. You need to already know that, Harry. This video I just showed you, eggshells. You need to already know what distance the hot sunspot is and prove to me it's the correct distance. It's fucking insane.
No, I'm just saying, it just doesn't fucking make sense to me. Like,
Nor it should it. If you don't want to make sense of it.
Away. What were you going to say, DJ?
Well, all I was going to say was, like, if you're comparing this to when you see the sun in the sky, right, and you have like the reflection coming from the water to your feet, right? This isn't the same as that, right? Because you can see the clouds. The cloud deck keeps going behind this round spot of light that's on the clouds, right? This isn't the same thing. Yeah. Like, it always comes from the farthest distance that you can see the horizon line to your feet when you're talking about that reflection off the water. But this is just a spot in a particular section on a cloud deck. It's just...
I agree.
Starts later.
It is weirder than when it's all just a straight line on the water. I agree with that.
Yeah, and a cloud isn't a shiny curved surface either. You know, like
I agree.
That's not how specular reflections work. They work on specific surfaces, and clouds don't meet that description.
I would certainly agree they work best. The smoother the surface, the better it is obvious, right? The more dusty and fluffy the surface gets, like clouds, the better it would be. And that's why I think my gut reaction to looking at that is I feel that's the water, but I'm maintaining a possibility that, like, enough fog, like, see how the cloud is all fluffy everywhere else? There's ridges and valleys and stuff in that cloud. What I'm just holding space for is, I don't know the settings for this camera. The sun seems massively overexposed, blah, 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 blah. And let's also count on the other side of this. So, yeah, I do admit it's a funny little patch.
It looks like it's right above that spot, doesn't it?
Yeah, it looks exactly like it's right above that spot. I 100% see why this is the video that's chosen to make that claim. All I'm saying is, which I think you would agree with as well, is if you regularly sent cameras up in balloons, and if there was ever a patch of ground that just had no cloud happening to go over it at the perfect angle, left to right, up and down, for the specular highlight to hit me in the eye, and it just happened there was cloud around that, then this is exactly what that would look like. Would you agree with that? It just would have to happen to be in the right spot, but it could have been in the right spot for any number of balloon cameras. So this must happen eventually, right? Cloud must just happen to be, because it's somewhere and it's not in other places and it is in some places, that sometimes must be empty of cloud right where the specular highlight should be. It would be improbable if it was always dodging specular highlight, knowing where balloons are going up and making sure it's always covered in a way that doesn't sometimes show it.
Yeah, I personally, I don't think that particular section of cloud is even really lit up. It's just that to that particular viewers and maybe to the viewers around it. I think if someone from a different location, looked, they wouldn't see that particular section lit up. I don't think that the physical sun is right above causing that hotspot. I think it's just like an apparent thing that we're seeing. It's some weird reflection, and the sun above it is probably apparent. I don't know. Everything about the sun and the way it reflects off things makes it seem like it
wins every time.
Your personal journey to change isn't a solo mission. Introducing Walden Wayfinder, guiding you through your bachelor's every step of the way. We map your career goals with comprehensive, personalized planning. And to help make those goals more attainable,